systems, interacting with the environment is all which have to look at when you talk about it. So along with this advantages or the foundations or a definition of this AI, we also have pros and cons. This particular thing I have taken from data flare. It's easily available in data in the internet. Okay, so I liked it. So does not get tired and wear out easily. Okay, as we all know, it is not wearing out or tired because it can do repetitive tasks throughout. Okay, it is a rational decision maker because whatever the rules and regulations which we humans gives, only that it does. It will not give, it will not do anything more than that. Okay, application in medical industry or application in a pharma or application in your design industry, architecture industry, or manufacturing industry, take anything, you have a pros or you have advantages of this AI. Or the power industry, accurate decision making based on already existing data. Okay, selfless with no breaks. That means it will not, it's unlike humans, it does throughout the day. Okay, throughout the night, it does not matter what time you are going to do it. Okay, similarly, the cons is incurs high cost. Guys, you have to look at the cost of developing a model is huge. Okay, coming up with a model, coming up with the data. See, we talk about data science, data analysis, data, but where exactly we have to collect this data, that is a huge challenge again. Okay, so in case if you go to any hospital, people will not give data just like that. Okay, you need to have lot many policies involved in that. So incurring, it's a high cost. It might lead to unemployment. Okay, no improvement with experience. So humans improve with their experience, right? Our efficiency goes higher and higher as our experience grow. Okay, but unlike that one, AI is just does the same job, whether it is 100 years, 200 years, or 1,000 years, it does same thing. It will not change it. But our problem, or we are trying to make it as intelligent as possible. We are trying to make artificial intelligence or the computer thing. That is what the challenge is. Lacks in creativity. It will not create anything new. It just does what exactly it is supposed to be doing. Okay, with this, so here we are that the latest areas domain using AI, that is NLP, that is computer visions, a speech processing, a time series analysis, or the healthcare, or any domain which you're talking about, the manufacturing or the power systems, etc. A lot many areas are talking about this latest areas, that is gaming with AI and code generation. If you go to the top companies, the generation of the code is automized now. From the Python, you are able to get C++. From C++, you are going to get C, etc. Okay, so how exactly it does? That is what intelligence is going to do. Okay, adversarial networks, that is adversarial attack or adversarial defense. How exactly data is poised? What is the inference of attack? These are the things which are going to be a part of this areas where AI is used. Knowledge based, that is linked or predictions knowledge, graph knowledge or the graph predictions. Music, if you go to any Netflix or if you go to the Spotify, there are a lot many platforms where it suggests based on your emotions. Okay, emotions. There is something called what is that called? It is a decision making thing. It will based on your emotions. Okay, based on your liking, it gives or suggests what exactly you are going to like. For example, in case if I like KGF2 or KGF1, okay, similar kind of movies will be suggested in Netflix. Okay, why it is? It is because based on various different parameters or based on your searches or based on your view, it is able to give some kind of inputs. Okay, so this is what this AI able to help all of us in our day-to-day life. Okay, so reasoning, decision making, making common sense reasoning, reinforcement learning, visual reasoning, and we have deep learning, transfer learning, and generative adversarial networks that I'm going to talk about little more in details about this. What exactly generated adversarial network? Everyone knows about it. What are the advancement happened in that? And then we call it as something called the explainable AI. Then we have a recommendation systems, as I spoke about Netflix, or if you talk Amazon Prime, or if you go to Spotify, etc. It is able to give a recommendations to you what kind of emotions you are currently. Morning time, you might get a soothing music. At the same time, when you talk about evening time, there might be jazzy movies or jazzy songs which might come up. Okay, it recommends for your emotions based on your requirements. Okay, UX, that user experience. If you go to the Amazon web page now or Amazon app, they have changed their experiences now. Did you see? Did you observe that? Every different day or every sometimes it is going to change its user interface and user experience. So it may be because of the way you are actually using the what is that? Using the application. Might be for me, it might be the interface might be different. For somebody else, it might be different based on your usage. Okay, that is where AI comes into picture again. Okay, if you go to road transport, how exactly this lights? You have this lights, right? Stop or you can go ahead. This lights is going to be switching on or switching off based on your movements. It can happen. Very, very, very different diverse applications which you are going to see. Okay, image generations. Okay, so we have seen in the latest forwards, we have seen that a still picture is able to move and sing a song based on the background music. Okay, that is how, for example, we have seen various different people who are celebrities are going to be singing for some song which is not that, and still their still picture is going to move. How exactly it is going to do? And then image generation or image reconstruction. How exactly we are able to construct the image based on the previous already existing data. Language modeling, machine translation, and cybersecurity and the big data, which is currently we are looking at. So what is big data? It is nothing but the 4 V's we know about. Volumes, the amount of volume data is coming every single second is huge. How exactly we are able to do some kind of analysis and come to a conclusion? Okay, so here areas of AI and some dependency here. Okay, so here areas of search, it depends upon a natural language processing. Okay, why? Because search has to happen based on the way you are typing, the way you are using the words. Okay, natural language processing is absolutely required there. Okay, so search depends upon the logic again. What kind of logic? Okay, so I am not human or I am human not. There is a difference. Okay, and similarly, knowledge representation and search are actually related. Similarly, search depends upon planning. Search depends upon machine learning. Search and the machine learning depends upon the vision. Okay, and also the data. And planning depends upon the robotics, and knowledge representations depends upon the expert system. So here there is a dependency, a lot of dependencies around. So search, NLP, vision, machine learning, all these are keywords, and we have various different dependencies here, and see how exactly it is able to talk to each other and come up with the expert AI for our needs. Okay, so with this, I'm going to go to the specific thing here. Okay, I want to talk about a generative adversarial network and also a explainable AI. Okay, so these two things which I want to discuss, because these are the latest trends which is currently happening. Advancement happened with GAN and also explainable AI, but I'm not going to go into the details about what exactly the advancement in GAN or explainable, but I'm going to talk just what exactly this means. Okay, so here you have a generator, or we have a random input vector, that means image or anything which you want to give as an input. And there is something called generator model based on the deep learning concepts, which is going to generate the model. And then this generated example and also the real example. For example, you are based on various different previous data, you're going to generate some image. And then with an actual image, you are going to compare. In case this both the generator and the real is going to give to the discriminator model. Okay, this discriminator model is going to find out whether the generated example and the real example are matching or not. Once, in case if it is not matched, then what exactly happens is it classifies as a fake one and asks the generator to recreate again. Okay, regeneration of it is going to happen here. Okay, again it comes back, again it classifies, again sees the real example. Then discriminator model, basically there are two things. One is generation and another is discriminator. Okay, generator generates and discriminator discriminates. Okay, so it discriminates until you'll get the almost the real one. Okay, so that is what this particular generator adversarial network is going to do. Okay, so here let me show what are the different examples here. Generator example for image data sets which we can use. Generate photographs of human faces we can do. Generate realistic photographs we can do. Okay, generate cartoons and characters we can do. We can do the image to image translation we can do. Text to image translation we can do. We can do semantic image to photo translation we can do. And then see, I do not know all of these things, but I know a few of them here. Okay, face aging, we have seen some AI based things which we have seen how exactly we are able to see after 25 years. Okay, when I become old, how I might look, it is that. Similarly, when I am at the childhood, how I might be looking at or how I might be seen as. Photograph can be edited, photo blending, super resolution, that means some of the low quality image or low pixel image can be resolved and get the high super resolutions. Photo in painting, that means in case if you lose some image, some part of your image or the photo, you can create that back using this GN again. Clothing translation, that means the colors, okay, various different colors, how exactly this person looks or this model looks like. Video predictions and 3D object generation. So these are the various different applications of GAN. Okay, so here is one example here. So here there are, if you see the leftmost one, you have a photo. Okay, you are able to generate man with glasses. Okay, and here man without glasses. You're subtracting and getting a woman without the glasses. And also we are able to get women with glasses here. Okay, this is the recreated one. This all the three down there are recreated one, and along with that you are able to recreate a woman with glasses. Okay, so you have a man with glass, man without glass, woman without glass, and then generated woman with glasses. Okay, so how exactly it's happening? You can use this GAN there. Okay, similarly, if you see the input is there. Okay, input, all these things are input. The left column, the first column, the second column is output, and reconstruction process happened here. Okay, so these are all. See what I'm trying to say here is not many applications use latest AI based things for their own application development. Okay, if you see here, generation, text to image conversions. Okay, here the search was the small bird has a red head with feathers that fade from red to gray from head to tail. Okay, this is what it is. So here what exactly happens? They have created the first stage 1 images. So it got generated with this. And while the stage 2, it went on and created the original one. Almost it is real, though it is not real. Okay, stage 2 images, it is almost real. Similarly, if you see, this bird is black with green and has a very short beak. Okay, this is the text given by somebody, Google search. Okay, so it created the image based on the search. How exactly it is done? It is done using generative adversarial applications. Okay, this bird is black and with green and has a very short beak. Based on this particular keywords, that means short beak, green, black, bird, etc. These are the keywords which is used and generated this image. How exactly it is generated? Using this something called the GANs. Okay, so here again, remove a rain from photo. Okay, this is what happened. If you see the first image, A is a original image, and you have cleared the rain in the second B image. Okay, the image you have actually made the rain thing very dull. That Okay. Similarly, if you go to the C and D, the C1 is the original image, and you recreated the D image by removing the rain. Okay. So just 1 second, sir. I'll just come 1 minute, 1 minute.
Okay, sir.
Yeah, I'm back. Sorry for the intervention here. Okay, so this is what the GANs is going to do. Okay, so here, okay, so this is what the GINs are actually is able to support in various different applications. Now I will move on to something called the explainable AI. Okay, what is artificial intelligence? Artificial intelligence is the one which actually supports the activity of humans, or trying to simulate the human intelligence, and using the technologies. Okay, what is explainable AI, which we have to look in. Okay, so till now we are using the tools, and we do not know why exactly the model is working like. Okay, why this AI problem? For example, if you use let us say CNN, or we use LSTM, or we use RNN, or we use GAN, but we do not know why this GAN is working, or why this CNN is working. We do not know. The why part is not seen. The why part is not there. Okay, so now we have to talk about this, something called the explainable AI. That means we are able to explain why this particular incident is happening, which is tools and frameworks to understand, interpret our machine learning models. Okay, we are trying to interpret the machine learning models. For now, we know, okay, if you give some input, black box approach gets the output, but we do not know why it is happening. We just know that it is happening. Okay, understand AI output and build trust on it. So based on the output, we are able to derive some conclusion, and also try to explain why this particular model is working like this. Okay, that is what we call it as AI, explainable AI. Design interpretable and inclusive AI. Deploy AI with confidence. So we know, okay, in case if we apply some algorithm, it works with some confidence. That means you have to build the particular AI such that the confidence level is really high. Streamline model governance. Okay, this is what again which you are going to look at. So here, if you see the last flow chart here, data is there, model fitting is there, and then there is an opaque model and surrogate model fitting. So this particular surrogate model fitting means you are creating one model fitting there and try to apply this model fitting and interpretable model here. Okay, then it explains. So from the opaque model, you are going to do what exactly explanation generation. So you might be coming up with some explanation for the particular model is working or not, then explanation is going to happen. Okay, so it is explainable AI is a set of tools and frameworks to help you understand and interpret predictions made by your machine learning models. Okay, so if we can debug and improve model performance and help others understand our model's behavior. Okay, so that is what we are talking about, something called the explainable AI. Okay, so deploy with AI with confidence. That means trying to give the confidence to the model such that we are able to explain about why this particular model is working. Grow end user trust and improve transparency with human interpretable explanation of machine learning models. Okay, currently anybody you go and speak, any business you go and speak, they say that, okay, I have used data science, or I have used this model. But if you ask them why it is working, nobody knows about it. That is where we computer scientists have to tell, okay, this is why it is working, or this is the reason why it is working. Why this particular image creation happened? What is the reason behind it? Is it because of precision, or is it because of predictions? Is it because of classifications? or is it because of what kind of model or what kind of mathematics which you have used? That is what we have to give with confidence. That is what we are giving a confidence to the customers or whatever it is. Okay. While explanations don't reveal any fundamental relationships in your data sample or population, they do reflect the patterns that model found in the data. Okay. That is what explainable AI is. Okay. So today, I want to see the difference here. AI versus explainable AI here. Today, training data, machine learning process, learn function is there, decision or recommendations which you are giving to the user. Okay. Again, give the task, it does only this one. Here in the explainable AI, if you see training data, new machine learning process, explainable model, explanation interface, and then the user is going to get. So why did you do that? Why not something else? When do you succeed? When do you fail? When can I trust you? How do I correct an error? No answer to all these things. Here, I understand why, I understand why not. I know when you are succeed, I know when you fail, I know when you trust, I know you erred. Okay, so explainable AI is the one which currently people are looking at, and how exactly it is working. That is what we have to contribute to the research community. Okay, so with this, I am just have a particular concepts of recent trends in AI. The thing which I'm going to talk about now is what is this exciting world of HPC for AI applications. Okay, so we have discussed about, see, people are there to talk about AI, people are there to talk about the models, people are able to talk about the machine learning and the deep learning, but the platform which is there, what are the different platforms required for these applications to be executed? Nobody talks about it. Nobody talks about what is the importance of this HPC, high performance computing. For every different computational intensive systems like AI requires some platform to execute. Okay, we currently, what we are doing is we are talking as, okay, we want a football, or we want to play football, but we do not have the platform to play the football. Okay, we are happy about playing cricket, we don't have a ground for it. Okay, we are good at shuttle badminton or any games which you talk, but we don't have a ground for it. Then what is the use of it? Right? So that is what we have. I'm actually focusing here now. Exciting world of HPC for these kind of applications or AI applications or any kind of a highly computational intensive applications, you require HPC there. Okay, so we have moved from experimental to simulation based research in most of the domains, including medical, pharma research, manufacturing, architecture, or the product based, etc. Everywhere we are using. We are lost in AI and ML, but there are opportunities in the area of HPC too. Okay, we have algorithm development, but we don't have a platform development there. People from the industry are looking at how exactly optimize this performance tuning, how we are waiting for the days together, weeks together to come up with the result. But unless we have a HPC platform, we are not able to come up with the immediate results. Okay, any AI related applications requires HPC platforms to execute it. There are two things which we have to focus on. AI and current market is efficient algorithm for applications and platform to execute these algorithms to be efficiently executed. Okay, these are the two things. So many of them are focusing on efficient algorithms for applications, but nobody talks about this platform to execute these algorithms to be efficiently executed. Not that nobody, very few are talking about these things. We have opportunities in that particular platforms, and we have to look into how exactly these algorithms can be tuned or performance can be gained. And as we all know, there are a lot many government of India is actually giving a lot of what is that? We have funding for HPC based research. We have IISc, which is working on supercomputing build up. Okay, various different market is looking at how exactly we are building a HPC platform for various different kind of applications. Okay, so these two has to go hand in hand. We can use this an opportunity to explore the HPC area. Okay, so we have a summit, or we have a nurse, permulator, all these are from US based computing facility. But we have a systems again in India. We have Param Siddhi or Param Yuva supercomputing machines, but not scaled up the way US has built, or the China has built, or Japan has built. We don't have, but that is where we have to focus on and also build how exactly it can be used efficiently for various different applications, guys. Okay, so exciting word here: performance tuning, profiling the correct word to identify the spots which are time consuming, parallelisms to fit the applications into various different architectures, applications development for supercomputers, benchmarking the performance of the different applications, etc., are the ones which we have to focus on and try to build such that we are able to efficiently use. Okay, so this is what I wanted to give in this particular talk. And also I want to tell that evolution of computer and algorithms are happening, and AI can be applied in any domain for efficiency. AI is a good field, but need to have good understanding of mathematics to come up with good models. I also wanted to emphasize on understanding of HPC because of its importance in AI applications. Confluence of AI plus HPC is going to be exciting. Okay, so if you see the diagram here, computer science we have artificial intelligence, machine learning, deep learning, big data, etc. HPC also is a huge thing which we Indians are lacking. We Indians have to focus on HPC also to come up with the various good things to make sure that we are able to apply this artificial machine learning, deep learning, or any big data analytics in these platforms, such that whole thing is going to become a computer science. Okay, so that's it from my side for this particular presentations. Thank you.
Thank you, sir. We now have the question and answer sessions open. If anyone has a query, you can post it in the chat box, or you can ask the sir directly.
Okay, so there are a few questions, madam. There is why rational action is most important for an AI agent. That is the first question. So rational action, because see, rational action means for every rational thinking is very important, right? So you cannot come up with for example, if I tell I want to go from a X place to Y place, I cannot reach to the Z place. I supposed to have what are the different ways or different optimal ways I need to go from X to Y. Or I would say, since all of you are from Coorg, I would say that, okay, let us say I want to go from Madikeri to Shuntikoppa or Shaniwara Sante. Okay, how do I go? Can I go and reach Sampaja or Sulya? Is it possible? It is not possible. Okay, I'm not supposed to. So rational action is required for the particular problem. That is what we have to build such a way that it is able to do the rational actions. Okay, so the next is how are game theory and artificial intelligence are related? So very nice question. So what is game theory? Game theory is the one which actually develops the concept of gaming. Okay, and AI is how the systems are able to think on its own. For example, while you are playing, somebody from the for example, you have built a model or the robot which actually starts firing around. Okay, some game is there. Or for example, you are driving a car. Okay, while you are driving a car game, even the car is able to tell that, okay, this is what you are driving is wrong. You have to turn left instead of right. This particular intelligence has to be given to the person who is playing the game. Okay, so that is what the game theory and artificial intelligence are related. Okay, so game theory is a theory where we are trying to build some of the games which is important for us, right? How does an AI generate images? That is what the question. I think I have answered this question in my talk. I think it was coming before I talked about GAN. Now, AI generate images based on the previous images, and also come up. It's called reconstructions or super resolutions. We can do it based on some kind of already existing data. We have huge data. Based on that, it is able to recreate. Now if you go, a lot of things are happening with 3D reconstructions from the 2D images. For example, if you want to simulate your body or your ortho based operations, for example, I want to simulate your knee from various different angles X-ray would have taken. Now based on the X-ray images, it is able to reconstruct the images or the 3D images. It is almost like your own leg. it is able to reconstruct it. That is where the images are important. That is where your various different parameters are important. Based on that, it is able to generate the images. So, sir, AI and deep learning are the same. This is the question. Mohan Kumar, AI is a huge domain. Deep learning is a part of it. AI is artificial intelligence. Deep learning is a technology or the algorithms which we use to make a system smarter. Okay, AI is a general one. A deep learning is specifically used to make a system better and better. How does, okay, the next question is, how does AI provide security? What kind of security you are talking about? In case if I am talking about the security, I expect that, okay, I will tell one reason. Okay, so let us say I'm talking about network security. I'll talk about network security now. Okay, let us say your particular modem is getting broken. Okay, let us say your modem is going to break or your internet is failing. Then before failing, we have to have various different parameters such that I am able to predict that this particular system or this particular modem is actually getting failed based on various different parameters. That is where AI is going to come into the picture and put the things in the perspective. That means you are going to predict based on previous data or the previous parameters. Okay, so what is the difference between HPC and AI? The HPC is a platform, AI is an concept. High performance computing is a platform. It's a platform for the various algorithms to be executed. You would have seen a sequential programming and parallel programming, right? The parallel programming you would have seen, parallel computations you would have seen, you would have heard about NVIDIA GPUs, you would have, right? So these are very important to execute your high-end applications like deep learning or machine learning or your various high-end computationally intensive applications to be executed. We have to parallelize the code. So we have number of systems that, okay, if you go to the, okay, if you, let me go here. If you go here, let me see here. These are the systems. Okay, the previously in 1980s, what the laptop you have currently is a supercomputer. 1980s or 1990s. Now they have built. You should be knowing about something called the Amdahl's law, or you might be know about the Moore's law. Okay, there is something called the Moore's law where you were writing a good code, sequential code, but because of the high frequency, your system got burnt. Because of that, they thought, why not go and talk about parallel computing or the multi-core architecture? Every laptop currently is coming up with a multiple different cores, right? So based on this, you are having a build these systems. These systems are built now. Okay. So this platform is HPC and AI is a algorithm based and trying to make computer smarter and smarter. Okay, so sir, how is AI related to machine learning? AI is related to machine learning because again the question of the deep learning comes here again. AI and machine learning is support of AI. I've shown this one, right? Let me go and show you again here. Okay, here if you see AI is there here, artificial intelligence. Under the artificial intelligence, go to the slide. I have gone to the summary slide here. Under the artificial intelligence, we have machine learning. Under the machine learning, we have deep learning. Okay, deep learning is very subset of machine learning. The machine learning is a subset of artificial intelligence, and we have with the artificial intelligence, we have many things around. Okay. Okay, so the next question is, can AI take over the world? That is what we have to decide on. That is where the policy comes into picture. That is where government comes into picture. What exactly we have to do it? For example, government has told that we cannot make a what is that, fast tag automation, or we will not take away the jobs of this fast tag. Based on the fast tag, we cannot remove the people there. Okay, some policy has come like that because it is losing the jobs. Okay, at the end of the day, what are the policies are important. Based on that, it is going to come and talk about it, right? So I cannot answer this question. Can AI take over the world? In case if that's the case, then we humans have to really seriously think about it. For me personally, if you ask me, I want artificial intelligence only to assist humans and not to replace humans. Okay, if you ask me, AI is the development which is done by humans, and we have to make sure that AI is not going to take over the world. Okay, yes, it is going to affect some job market, but you need to have various different approaches, or the skills has to be different. The skills of previous one and the skills of current one is different, but we cannot be compromising on replacing the humans. It's not possible. Okay, that is what I want to talk about it. Okay, so these are the questions which are there. So I am done with the my presentations. Thank you. So I want to tell. Okay, here are the few acknowledgements which I want to give. First of all, my institution, Acharya Institutes, Bangalore. And then I want to acknowledge management, the Coorg Institute of Technology, for giving an opportunity. And principal, Basavaraj sir, I know because of our common friend. Thank you, sir, and the organizing committee for this fantastic conference. Thank you.
Thank you, sir, for the highly informative session. The difference of AI with other similar concepts was greatly clarified by you. We look forward to have more sessions from you, sir. Thank you very much, sir. I request you to provide your email ID in the chat box, sir, so that our participants, if they have any doubt, they can revert back to you, sir. Thank you, sir. Participants, we shall have the next session at 11:30. The session is from Mr. Aman Chaurasia, and the topic is preparing students for competitive programming. I request you all to join using the same link at 11:30. Thank you.
I'm just putting one more email ID, personally my ID, in case if somebody wants.
Okay, sir. Thank you.
Okay, there are two. One is official Acharyas. Another one is a personal. This one email.
Thanks a lot, sir. Thank you.
Oh, they left early.
என்ன இல்ல Start.
Aman sir, shall we start the session?
Yeah, we can start the session. Yeah. Am I audible?
Yes, sir.
Okay.
Sir, will you share the screen?
Yep, sure.
Okay, sir. I welcome all the participants after the break. We now have a session by Mr. Aman Chaurasia, Software Engineer Google, on the topic Preparing Students for Competitive Programming. I now request Professor Nidhi, Assistant Professor, Department of Computer Science and Engineering, to introduce our resource person.
So hello everyone. It's a great honor for me to introduce and welcome the resource person, Mr. Aman Chaurasia. He did his BTech from Indira Gandhi Engineering College, Madhya Pradesh in 2017. He has around 4.5 years of industry experience in companies such as Ribbon, Amazon, and Google. He has worked on cloud platforms, security, web development, and Google Cloud. His interests include solo bike riding, reading books, competitive programming, and talking about technology. Thank you. So now I request Mr. Aman Chaurasia, sir, to continue with the session.
Yep. Thanks for the introduction. Yep. Yep. Can you please confirm if you can see my screen and the presentation?
Yes, sir. The screen is visible.
Okay. Yeah, sure then. Yeah, we are good to go. Yeah. Hello everyone. I'm Aman Chaurasia. So currently I'm working as a software engineer at Google. And in this session, I will just try to touch upon on the surface of the competitive programming and what it is and how it can benefit the students to create future prospects in their career, right? So before that, I think I think you guys have already introduced me, but I will introduce myself also. So yeah, I graduated in 2017, and I worked for 4 years in event communications.
Excuse
And then
me,
after
sir.
that,
Sir,
I
sorry to interrupt you, sir. So, dear
Yep.
participants, whatever the questions you have, please share in the type in the chat box. At the end, sir will address all those questions. Thank you.
Yeah, on that means if you have any questions, I think I'm able to take up the head of question also. Because otherwise, if I'm talking for 1.5 hours, it will be too monotonous for everyone. So yeah, means if it is possible, you can just unmute yourself and ask the question. That is also okay for me because anyway, I won't be going too much in the technical depth, so it will be just the conversation. And if you can, then just ask me the question in between also. Yeah. Okay. Yeah. So yeah, for 4 years I worked in driven communications as a software engineer. Then later on I moved on to Amazon and worked there for I think 3-4 months, and then currently I'm working at Google, right? So yeah, so my journey has been I think has gone through a lot of tremendous change because I think if I just brief me about my personal life before engineering, right? So before that means when I completed my high school, at that time when I was about to choose my stream and all, right? Since I come from a very remote town, so at that time I wasn't even aware of what computers are, what internet is. All I knew that these are some machines and the guys in the computer cafe and the government offices use them, and then from there to coming and into the software industry and then making living out of it. So I have seen a lot of change in myself, and means if you can relate to me, then I think it will be good. So in this session, I'm planning to cover these many topics about the competitive programming. So first thing, I think we'll just briefly discuss about that. What are the gaps between in the market and the various company requirements, right? And then what we are not finding in the students that are coming fresh out of college, right? Because I keep taking interviews and all, and I see some of the gaps that we can fill maybe right from the college level, so that the students are ready when they come out of college and search for jobs. Then we'll touch upon the computer programming. Means what is it, why we should do it, and and then we'll touch upon the technical interviews as well. How this computer programming is relevant into technical interviews, right? And how this is impacting into the job market, and how it is shifting the job market to some other level, right? And then we'll discuss about the miscellaneous steps and all. So yeah, I think this session is around 1.5 hours. Yeah, 1.5 hours, right? It's too long of time. So to keep you guys awake, I just have a quiz for you guys, right? If you can just tell me that what these two pieces of code are doing, then I think we can get the conversation started. Was otherwise, if I just keep talking for 1.5 hours, every one of you will be asleep. So yeah, just take a guess what this code might be doing. It's just a very simple code. Don't worry if you are wrong. Also, it doesn't matter. I also get them wrong sometimes. So anyone up? Anyone still not asleep or okay? Yeah, I'll just describe, right? So these are two code written for solving the same problem, right? The code on the left side, what it is doing, it is just calculating the sum from 1 to n numbers, right? And it is returning the result. The second code on the right is also doing the same thing, right? But what's the difference between these two code, right? So the first code is written by a computer science graduate who just graduated from college, and he has learned the basic data structures and algorithms, and he has done coding and all. So he is able to write the code which is on the left. But
So it's a recursive function.
Yeah. Sorry.
Recursive.
Yeah. No. Yeah. Means it's not recursive function. So yeah, means you can take a guess. So the code that is written on the right, that is also doing the same thing, but it is using some mathematical concept, right? We might have heard from, or we might have learned in our high school, right, that to calculate the sum from 1 to n numbers, right, we can use the formula n into n plus 1 divided by 2, right? That is as simple as that. But most of the computer science graduates will take the solution on the left because they have just known about programming, and then they know about loops, functions, variables, everything. So they will slightly go to the solution which is on the left, but that is not efficient, right? Means the solution on the left depends on the value of n. If the value of n is a billion times, right, or somewhere around a billion, then this loop will run billion times. And when you work on some real production data, that is not acceptable, right? It might take hours or days to compute. But the code on the right is just a single line and single operation function, that is, and which is a mathematical function, right? So it can just calculate it in the constant time, no matter how much the value of n is, right? So I just wanted to touch on these examples to, I mean, maybe just uh, show you the difference, right? How a normal computer science graduate will think, and how a computer science graduate who has done some little bit of computer coding also, or maybe some problem solving, right? How he will think. So if he have done some computer coding, then he will go to the right, because he knows that it can be solved in a constant time, and then there is no need to just loop over all the elements and calculate the sum. So I think so. These are the gaps that I see, right? As we discussed earlier, right? So means students coming out of college, they have. So I'll be talking mostly about the coding part. I'm not touching about the all other computer science fundamentals, because those are must and will remain must as we even if 50 years after. So students coming out of college, right? They know trees, graphs, and some of the complex algorithms, maybe traveling salesman, Freud, Warsel, Prism algorithm, and everything, right? But they might not know how to reverse a binary search tree. And in interviews or maybe in real world, right, you don't need to implement trees and graphs and all, but you need to solve some problems. For example, if so reversing a binary search tree is just flipping it from left to right? For example, when you see in a mirror, right, so your image is flipped from left to right. Suppose if you have an image in your desktop and you want to flip it from left to right, and you write a code for that, then you will write some algorithm similar to this, right? Reversing a binary search tree, that you will just flip all the bits from left to right and right to left like that. And if you don't know these algorithms, then all your knowledge on trees, graphs, and all other algorithms is not much of use, right? So that's why the industry tests you on these algorithms, which will be used in real world problems, right? For example, the other example we can take that the sorting and the sorting is, I think, very prominent topic in all the data structure classes and all, right? And if you ask any student, they will tell, okay, the quicksort and merge sort are the best, and they should be used everywhere. But then why not the default sort function of every programming language use this plain quicksort or merge sort, right? Why Python uses some different kind of sort or Java uses some different kind of sort, and why they are always used in combination of one or another, right? And the other gap that I see is that thinking of edge cases, right? Because the code that we write or the solutions that we write in college are just plain simple solutions which can cover the basic use cases, right, or basic test cases. But we are not able to think that what if the input is like that, or some input is corrupted? What happens in that scenario? Will our code handle that or not? Because believe me or not, most of the um, global outages that happen in big tech companies, right? For example, Google, Facebook, Microsoft, the some of the outages keep happening, right? Suppose I think a few months back, I think the GitHub was down, and most of the developers use the GitHub for their projects and all, right? It was down. So, what was the case in that? It might be a case that someone might have missed some edge case, which they thought, okay, that this might never come, but it came, right? So we don't plan into that scenario when we do it in college, but when we go into companies or when we at least do in the coding interviews also, right? It is expected that you think of all the edge cases before, even before you write the solution. Otherwise, uh, there are consequences for that, right? And other example is order of n and order of 2n, right? In the colleges, we are taught that means whatever the constant is, means I think you might be aware of this asymptotic means what do we say, big O notations, right? So that they show the complexity of any solution, right? So, and if we just took if we take that lens and then see both of these are similar, right? Because the constant head doesn't add any value there. So as a computer science graduate, if you are making an order of n solution, then you might be happy with it, even if order of n solution is possible. But in real world, for example, if you're launching a satellite to Mars, right, and then in that case, the order of n and order of 2n can make a really big impact, right? Uh, or for example, right now we are dealing in milliseconds and microseconds, right? And the blink of an eye is in 200 milliseconds. Suppose your website loads in 150 milliseconds, so the users won't notice the lag, right? But what if it takes double the time? It goes into 300 milliseconds, and now it is beyond the eye blink time of humans. The humans will notice that website is slow, and they might not go to your product and go to some competition, right? So that can be a huge business impact. So that's why it means theoretically these are almost same, but practically we have to think about it, that are they fully optimized or not, even though they are at the same complexity level. So to fill in these gaps, right, competitive programming comes into play, right? So what is competitive programming? So it's not just that it's just a competition and sport, right? It is just a common platform for everyone to just practice their problem solving skills and improve on them, right? For example, if someone has visited some competitive programming website, then they might already know that how to reverse or mirror a binary search tree, or maybe find the sum from a 1 to n in constant time. Because there you get all the tools and platform and all the instructions, right, to make your code according to what is required. And I always believe that engineers are always the problem solvers, right? Because means we engineers are built to solve the problems that are there and make people lives easy, right? And that is where this competitive program also helps, right? Because it gives you a platform to just practice and then learn from other portals also. Because what really happens that we create some solution, we write some algorithm, and we think it is perfect. But yeah, it might be perfect, but uh, these platforms are global, right? So the participants are participating from all over the world, and you never know, there might be some better solution than you, right? Or you might get to know some other approach for the same solution, and then you can use it for some other problem also, or maybe some other, or solving some other problem, right? So these things also we get to learn about when we do competitive programming. So are you guys means any one of you aware what lead code is? Can you answer? Okay. Okay, yep. So this lead code is just one platform where we can do some competitive coding and all and practice, right? So suppose if you means if I think that I'm good in binary trees, right? And I think that I know all the operations, all the possible algorithms, all the problems that I can that are possible on binary trees, and I can solve them. Then just go to the lead code, right? Lead code is just a platform, and you can just choose the topic as binary search tree, and then you will find hundred of questions from that based on the difficulty level. You can choose. Means if you think that you are a pro, then you can go for hard question, which only maybe which has an acceptance rate of 1 or 2%. It means that 100 people submitted and only 1 or 2 people code got submitted. Then if you can solve that, then I think it will build up your confidence that you are in the top 1% of the world, right, to solve that problem. So this is how we can use use these platforms, and I think there are a lot more. We'll discuss about them later on. So why computer programming, right? So it's not just about the job interviews and all. You might we might use these concepts uh, in our real work also, right? For example, because right now, right, what I would say, okay, right now, right, we are means the technology is moving pretty fast, right? So if you are building up some expertise and some technology, and in 2 3 years it goes extinct and new technology comes, then your the knowledge or means the expertise you got is lost, right? But the coding and the problem solvings are there. It has been there for last 20 years, and maybe it will be there in next 50 20 years, right? It will never go away. So that's why it is always good to invest your time into problem solving and developing the problem solving skills, because not even in coding, some real scenarios also you can use them and get benefited from it. Or for students, how it is useful, right? So first of all, if you do computer programming, then your problem solving skills gets better, and you get a and as you keep doing good and good, right, your reputation in these platforms keeps getting improved, right? So now you can get a means you get a good visibility on that platform, and it may happen that some of the top level companies are keeping a watch on all the top performers on all these platforms, and then they might offer you with some interview opportunities or the job opportunities, right? So it has happened in uh, with some of my friends, and I think I would recommend all the students to do it also, because sometimes getting the opportunities is very difficult, and if you can get an opportunity while improving your skills, I think it's a good add-on, right? And the competitive programming is also a thing where your background doesn't matter. If you know how to solve a problem and if you know how to write, it doesn't matter which background you are coming from, if you are from electrical, electronics, from mechanical, civil, right? Because I have seen a lot of people doing competitive programming, and even though they were not from the computer science background, they have successfully cracked the interviews of top companies, for example Google, Facebook, and Amazon. And I personally know them, so I can confirm that. So that's why it is a very good platform to just showcase your skills and enhance your career. So I was just talking about the job opportunities, right? Here is another platform named Hacker Earth, right? For the whole year, it keeps conducting, means the companies keep conducting all the hiring challenges and all. So suppose if you want to prove yourself that okay, you are good at problem solving, and you are looking for some good opportunities in some good companies, right? You can just go to some of these platforms and then start the hiring challenge. It will be just like the same. You will be given some questions, you submit it, and then based on that you get some rank, and maybe companies might decide that okay, now maybe the top 100 candidates I will take and call for the interviews. So this is also a good way to get the job opportunities. And so I think maybe the very starting job that the students get is the internship, right? So in internship, we think that okay, it will be very light and there won't be much of a hassle, right? We can just do some basic preparation and we can get started with it. But that is not the case with now, right? If you see this is also uh, a snapshot I took from Hacker Earth, right? They had this winter internship challenge, and in the challenge format, if you see, and the first thing is two programming questions on DS and Algo, right? So even for internships also, they are asking for this competitive level questions, and you have to solve it to get the internship. It's not now like that they will ask some questions from databases and operating system, and if you're good them or if you just skim through them, you will get selected. Now, means the computer science fundamentals are still necessary, but those are not enough in today's world. So now, along with that, you will need some good computer coding or maybe some problem solving skills to get into some good companies. And the interviews are also changing, right? So I think I have been conducting interviews and I've been giving interviews, I think in whole 2021, right? So I can relate to it more. So now it's not, most of the companies are not conducting technical interviews. They're conducting coding interviews. So earlier what used to happen, they used to ask about your previous work. Means if you're fresher, then they will ask um, some questions from your maybe CS fundamentals from databases, operating system networking, right? And then it used to be all. And then in the end, they might ask about something like loops or interfaces or some other concepts in some programming languages. But that is not the case now, because since the competition is going higher, so it is already expected that you already perfected all the CS fundamentals. But along with that, you need to show the problem solving skills in the interviews. So the interviews goes like this, that maybe at least what I have given, that in interview start, they will just give you a question, they will explain you the scenario, then you have to build a solution for that, and then you have to explain and then optimize and then handle all the edge cases. And there is not even a single talk about the technical domain knowledge that you already have. It is true, means it is mostly true for freshers and for the experienced person also, right? So means at least this is what this I have faced, and I think this is I see this recent trend in the industry. So in that also, this competitive coding helps, because if you're already good at competitive coding and problem solving, then I think going through the interviews, even if it is technical or not, or the coding one, you can easily get past through it. Any questions till now? Or if there are questions in the chat, you can just read me out.
Sir, we have few questions in chat box. We thought of discussing it later, sir. That's what we do in all the sessions. At the end, we discuss all the questions, sir. Is that okay with you, sir, or you want me to read it now?
Yeah, I think it means if you want, then yeah, we can do it your way only. Okay. Yep. I'll move next.
Okay.
So yeah. So the next we'll discuss that how the job market dynamics are changing, right? So means most of the uh, I think in 20 years back, right? Means 20 years back is the where the technologies were not that prominent, right? Most of the companies have already got the low hanging fruits, right? For example, creating an operating system, creating some network protocols, some search engine, some social media website, something, right? So those are some low hanging fruits which are obvious, and they grab them. But now most of the companies that are coming, right, or maybe the new companies are coming, so they are means for them it's more challenging because they have to search for a problem, and then they have to solve it in a unique way which hasn't been solved before, right? And for that they will need some good competent engineers which are good at problem solving, because most of the companies which are innovating currently right now, right, they are exploring a space which has not been currently explored much, right? So that's why they are not much interested in the domain knowledge. They are more interested in your problem solving skills, because they will see a problem and then they want you to come up with a solution, and then they can go to the market. For example, uh, I'll just take the example of Dream 11, right? Dream 11 you might have known, I think in last 2 3 years. So because it was also a very new market, right? The online gaming platform. It was also a very new platform, new market space for them. They created a space for themselves, and then they are the market leader. And if we just see at the market valuation for Dream 11, it's $8 billion, right? It's $8 billion. It's not just in millions; it's in billions. And earlier, what used to happen in IT companies, that it used to take around 1,000, 2,000, or maybe more than that employees, and maybe 20, 30 years in the industry to reach even $1 billion market cap. But this company, I think, started maybe 3, 4 years back, is now having $8 billion valuation. Why? Because now the markets are changing pretty fast, and if you come up with a solution which is not present in the market, you can get really far, and even far than the existing company which are there in market for 20, 30 years, right? So for that they need good problem solving engineers, and that's where this problem solving via competitive programming can help for the students to prepare and to enter these companies and enter the job market. So, so means what we can do, right? Because I think in the top colleges that I know, means in the US and all, right, they already have this culture of competitive coding in the among the students. Means, for example, you might be giving your students some assignments, right? And so there the assignments are like that. Okay, today is it means this weekend we have a lead codes online coding competition, right? Why don't you guys just register to it and participate, and then can please share the ranks that you get in that competition, and then we'll use this for assessment, right? So we can also means, and at least we can at least introduce the students to these online coding platforms, right? So that at least they can know that how much means what is their skill level in problem solving, and if they are not much, right, then they can regularly participate and then keep track of the progress, and then become better at it, right? And these platforms also helps in building a good reputation. For example, if I am on lead code and I have a ranking of around maybe 10,000 or something, right? And 10,000 is a really good ranking in lead code, because programmers and problem solvers from all over the world are participating. And suppose I add that ranking into my resume, and then because I think there are a lot of job applications going on into all the companies, right? Maybe the recruiters hardly take maybe 10 or 15 seconds to look at each resume. So then this ranking can make them stand out to the other candidates, right? For example, I get contacted on LinkedIn frequently, right, asking for referrals and all, and most of the people just say that I'm good at this, I'm good at that, I have this much CGPA, I have this much ranking, this and that. But if they tell me that they are regularly coding on this is the platform and this is the ranking I have, then I already know about their skill levels and all, right? That okay, that they have proved themselves into the global platform, and I think they are good candidate for my company, and I can refer them. So it can be a make and break parameter for students, or means the fresh graduates who are planning to enter the job market, right? It can be a very good parameter to differentiate themselves from others which are not good in problem solving. So how it can be used, I think we already discussed that. Means competitive programming will help everyone to prepare for the coding interviews, because now the interviews are not technical interviews, they are coding interviews most of the time, right? And it can build up a confidence in the students, okay, that if I can compete in million people and I can grab a rank of 10,000, then there are only 100 people being interviewed today, and I can surely beat them and get the opportunity, right? And they can increase their portfolio. And because I have seen a lot of people getting contacted by companies directly from these platforms, that because they keep track of all the top performers, and then they ask that are you planning, means will you be able to work with us, and if you like that, then you can join that, right? So the job hunting, because I think the purpose of education, it should be, means at least for some part, should be to make the people employable, right? And if the competitive programming helps in some way, then I think we should be encouraging it, right? And Since yeah, and one more thing, yeah, well, I think it means since these competitions are conducted globally, right? So sometimes it happens, for example, in ICPC, there's the coding competition conducted by Google. So we get to participate with some other team members from other countries, right? We go there, we participate with them, we learn from them, we learn from the solution. We get to know that okay, what kind of things work, means how the things are working in other part of the world, how the students look like there, right, and how they are preparing for all these things. So this also provides some learning opportunities for all the students. And now it's online. Now means everything is online, right? So that is also means I think a best way to collaborate with the other people and look for and learn from them. I, I think these are some of the coding platforms that I think means we can refer to. Uh, I won't go into detail in these platforms. I think maybe when you visit or when the students visit these platforms, they will understand that how to use these platforms. Because I think competitive program is really new. When I graduated in 2017, I think I don't think there was much talk about this competitive coding and all. But now I think every other student and that I meet or talk with, I think is already aware of all these platforms. Was and the prominent one being the lead code. So I'll just share my story. So means that when I was first contacted from Google, right? I was contacted by Google. So they told me that you need to be prepared with this and that. And I told it, where should I prepare? Then they told me, okay, you don't know what lead code? Because at that time I wasn't aware of that. And after that only I got to know the lead code and then other stuff. So this new means this much new lead code is, I think it's been popular for 2-3 years only. But most of the companies are referring to this. Even some of my colleagues or friends in some other universities in US, right? And for them, I think they got introduced with these things in first year itself, and for the 4 years they keep doing these things, and then they become very good at problem solving when they graduate. And then for them, getting good opportunities is not a big task, right? So I think if we can also do the same, and if we can, because these things don't take much time. Means if a student can dedicate 1 or 2 hours in a week also, and if the student has a long time to prepare, then I think um, there will be a lot of opportunities open when the student graduates from the college. Because domain knowledge is there and will be there, but currently the problem solving is the most prominent thing that companies want. And I think that it's because of the top companies are doing it. So also following the same pattern, the other companies are also doing that. For example, if you just apply for a job, right, the first thing that you get is the online test. And this test is not just MCQ or anything, it's just a coding test, maybe on the hackering test. And I think it happened with me when I applied for Amazon. They just sent me a test, and then they told me if you pass, then only we'll see if you want to interview them, if you interview me or not, right? So I just since I was already doing computer coding for some time, so I was even easily able to take the test and finish it and get good submission on that. And then I was called for interviews. Because what happens that interviews are not that difficult sometimes, but this test, most of the students, because these tests are designed to filter out the students, right? So that's why the test is the most difficult part. And if you are regularly coding on these platforms, then you might be already used to all these kind of problems. So it becomes easy for them to crack it. And I think everything we have already discussed the next steps, right? Which means we can encourage the students to just use these platforms and then monitor their progress, right? And maybe at the we can conduct these competitions at the maybe at the college level, right? So that and we can reward the top performers so that at least they get some motivation to perform good, right? And then maybe we can use these assessment, means we can use these rankings and all as part of some internal assessment, right? We already have some internal assessment uh, platform, right, where we just maybe we might be conducting some mid-semester tests or something, and then the assignment submission and all. So we can include this also as part of that, so that students will be more interested in that. and then it can benefit them in the long term. So yeah, I think for means I think that's what I was planning to cover in this session. I think next is yeah. So I think now is the time to take up the questions.
Okay, sir. Participants, you can post your questions in chat box. First question is, sir, what is the use of competitive programming?
Mhm.
That
Yeah.
is
So first, yeah. So I think competitive programming develops the problem-solving skills, right? And most of the means I think most of the engineering maybe because we are talking about the CS only, but even if other in other streams also, right? It's just about we engineers are just about solving the problems. So it goes same it goes the same way into the computer science also. That means with competitive programming we develop our problem-solving skills, right? And then we can make use of them to solve some problems which were not solved before, right? Or maybe and so because of that the companies are also demanding this because the companies are trying to solve some problems which hasn't been solved and they want the employees to means they want the participation, right? Because without employees the companies can't do anything. So that's why they are searching for those people only who are good at problem solving so that they can bring forward their mission and then they can collectively solve the problem that they are trying to solve. Does that answer the question?
yes, yes. The next question is, what technical skills are required for students before joining? That is before joining IT.
Oh, yep. So, yep, I think previously, I think it was that only means people from CS background used to come into the IT industry. But recently, I see a trend that people from other backgrounds are also entering into the IT industry. And I think the means the major factor is this problem solving and competitive coding. Because no matter what role you take as a software engineer in your company, right? If you are working on databases, networks, or operating system, or some cloud or something, the one thing that you will be doing is coding, right? And then building some logic. So I think the means the people who have this skill, right? The problem solving skill and the coding skill, they can easily enter into the IT industry. There is no barrier of um, any stream or any background. Anyone can enter.
The next question, sir. How to encourage students to learn coding? Do you recommend any tools to do that?
Yeah, I would suggest maybe so I'm assumed that I think the college is means the college education still works the same way that I went through. So in college we might be giving some assignments to write them down, right? Means I also used to find it pretty difficult and not much of use to uh, write everything I know into the paper and then submit it, right? But if even though for example in my class it was a data sisters class, but it's still they used to give us the pen and paper or to complete the assignment, right? But why not just do it online and then submit the code, right? So at least because you never know. Was I think my I started coding when I first just executed a couple of lines of code when I got my first laptop, and then it amazed me, right? That I could see a lot of future possibilities that I can do it at my fingertips, right? I can just change one line of code and it will be a different thing. So I would suggest that maybe if you means if you can encourage students to just do all of these things which were supposed to be coding, but we are telling them to write down on paper. If we can do it on online or some coding platform, right? Then I think it can develop interest in them.
The next question. Sir, can we do practice question in lead code?
Yes, so lead code is mostly for practicing only. So I think it has currently, last I checked, it had almost 3,000 questions, right? So, so based on your interest and topic and your level of expertise, right? You can already means you can already practice all these things. If Okay, I'm still sharing my screen, right? So I have already opened the lead code, right? So means I'll just tell you how it goes, right? So it has some coding contests that are going on weekly, right? But it has some problems, set of problems, right? And then it has a long list of problems, and then you can just select the difficulty level topic, something, and then you can get started with it. So and we are good to go. And it's not bound to any programming language. It means here is the question prompt, right? What you have to do. Here you have to write the code, and you can choose the language, any language you are comfortable with, right? And the best thing is that it it runs your code into maybe hundreds of test cases which you have never thought of, right? You might write from some code a plus b, but what if a is negative, b is negative, a is zero, or a is not integer, something like that, right? So these kind of things also test. You don't have to test anything, but the only thing you have to do that you have to think of all the scenarios and then code it out. And then when you run the code, you see the result that if your code is running fine or not. And when you submit, then only it runs all those hidden test cases that you should have thought of before designing the solution, right? And if you're good to go, then you're good to go. And the other thing this platform has is the discuss section. That is, I think, the gold mine, right? So here people like me and you, right, they just uh, solve the problem and then they try to explain it with the different approaches and all. You can see the different approaches, you can see their code, and then they will see and they will explain everything, that how my code works with all those complexities and how I'm handling all these test cases and all. I think it's a really good thing to just work upon here.
Okay, the next question, how to improve programming skills in students?
Mhm. Yeah, I think so. I think maybe the properly rewarding them, right? So I think the point that I touched on, right? If it means if I was in college and I was rewarded, if I'm getting a better rank in some online coding competition, or maybe just means if there is some coding assignment and I'm doing it better way, right? Means the optimal way, then I would be really happy. And then or if I don't do it good this time, then I will just try to do it next time. That will really help me to just improve on my coding skills. Means if I means I think it depends on the means management and all, but I think if we can encourage students to take participate in them and make it part of their curriculum, right? Maybe some part of assessment, then I think they might be really interested in, and then they can gradually improve upon it.
Okay, sir. Sir, could you please provide your mail ID in the chat box so that if any participants have any doubts, they can approach you, sir?
Okay, yep. I think in the presentation I've already shared my LinkedIn URL,
Okay, sir.
so you guys can connect me there and message me. So yeah, I frequently keep responding to the messages that I received on LinkedIn. So you can just connect me there.
Okay. We thank you for enhancing our knowledge on competitive programming skills, sir. We look forward to have more programs from you. Thank you, sir.
Yep, thanks. Yeah, thanks for inviting me. I think I hope most of you are still awake, because I think it was a really monotonous session. Means no one of you asked in between, so I don't know how it went, but yeah, thanks for inviting.
It went on well, sir. They have
Yep.
posted whatever queries they had in the chat box, and you have answered everything. It went on well, sir. Thank you so much for the session, sir.
Yep. Thank you.
Participants, next session will be at 2 o'clock. We have the session by cloud computing and microservices by Mr. Gautam, Director of Software Engineering, Ribbon Communications, and Mr. Dhananjay, Manager of Software Engineering, Ribbon Communications. The session will go in parallel. So I request all of you to rejoin at 2 p.m. Thank you.
Hello. So Dhananjay sir, hello. Is it audible to you?
Hey, Ramakrishna sir. Hello. Yep, I can hear.
I think Gautam sir also joined the session.
Yep.
Shall we cross check once then?
Hi, sir. Can you hear me?
Yes, sir. I can hear you.
Great. Thank you.
Can you share the screen, sir, just for the testing purpose?
Sure. I'll do that.
Yes.
Just sharing my screen. Let me know once you.
Yes. It is visible, sir.
Perfect.
Yes, sir. So within 2-3 minutes, we'll start the session, sir.
Sure. Sounds good.
Good afternoon, sir. We are waiting for a few more participants to join. We shall start in 5 minutes, sir.
Yeah, sure, ma'am.
Good afternoon, everyone. I welcome you all to the afternoon session of the refresher program on computer science and engineering organized by AICTE and AISTE, New Delhi. Today, we have the sessions by Mr. Gautam Nimagada and Mr. Dhananjay Ajeru, both from Ribbon Communications. And the topic of the session is cloud computing and microservices. I now request Professor Nidhishri, Assistant Professor, Department of Computer Science and Engineering, to introduce our resource persons for the session.
Good afternoon, everyone. It's a great honor for me to introduce and welcome the resource persons. Mr. Gautam Nimagada is the Director of Software Engineering at Ribbon Communications, an MNC powering the real-time communications at the world's largest telecom networks. He has over 25 years of experience in the IT industries at various roles and responsibilities. Earlier, he worked at India's Premier Technology Development Center, CDOT, Bell Labs, USA, and some startups. He is a technologist and loves to work with young talent and building teams. His interest includes reading non-fiction books, listening to podcasts, and traveling. Now, I would like to introduce Mr. Dhananjay Ajeru, sir. He did his BTech from RV College of Engineering, Bangalore. He has around 10 years of experience in software industry. He is a keen observer and aims to try bridging the gap between industry and the classroom. His interests include singing, listening music, reading books, and traveling. Thank you. So now I would like to call Mr. Dhananjay Ajeru, sir, and Gautam Nimagada, sir, to continue with the session. Thank you.
Thank you, ma'am. Thanks for all the nice introduction. Really appreciate. So here I have my colleague and a friend, Dhananjay Ajeru, with me. I'm right now in Bangalore, and he's in somewhere near Bangalore. Okay, and we are talking over the cloud communication, of course, right? What else can be a better introduction than to the cloud computing than that? First of all, before we jump into that, I would like to thank CIT and everyone here that is part of this, organizing this event, as well as participants listening in and looking for some insights and guidelines and whatever information we can share. It is really honored, and I'm really honored and excited to talk to so many of the educators at once from across India. So this is a great opportunity, I feel, for me, because sometimes I get asked, like, if you don't have to work for money, what would you do? I say I would teach. Okay, so in a way, you all are on my dream in my dream job. Okay, so I'm really honored to talk to all of you at once, and looking forward for more and more communication and interacting more with you. I would like to briefly tell about myself, and then Dhananjay will introduce himself a bit more and his background. Then we jump into the details and why we are doing this. So at a very broad level, this is split into why we are doing this, the purpose of this, and the core topic, that is cloud computing and microservices itself. And then we'll get into key takeaways and how we can help build the right talent that is ready for the industry, not only ready for the industry, drives the industry and innovates within the industry, and leads the industry. Okay. I graduated from JNTU Hyderabad, and after that worked at CDOT at that time, which are one of the premier institutions from the central government of India. And later on, explored quite a few things at multiple countries and companies. Worked for some time in Singapore, and then more than a decade in US at various roles and companies, including startups, and a little bit in Japan. That's a great country to learn about hardworking and culture. And later on, about 10 years back, came back to India and working for Ribbon Communications. Okay, so here, when I started my career, it was back then, right? Like there was absolutely no computers at home. It's a dream for many, but not at all reachable. All you learn about is by reading books. Okay? All you experiment is when you are in the office. And when I joined, absolutely no introduction to much programming other than maybe like, microcontrollers and microprocessors. That's about it because I'm from ECE background, but learned everything on job. Right? But now the things have changed so much in the last couple of decades. The expectations from the young talent has changed quite significantly. Right? So by the time the industry want to talk to them, they're expected to know so many different technologies. And this is our attempt to bridge that gap and make the educators, that is you, aware of what is happening in the industry, so that you can magnify that and apply that and lead your students and bring them not only up to speed, show the direction to the industry itself. At some point we'll get there. And so that is what actually motivates me to come here and talk. Okay, so that's brief about myself, and I'll let Dhananjay talk about himself a little bit, and then we'll jump into details. Dhananjay?
Yeah, thanks, Gautam. And after explaining your colorful journey and vast experience of 25 years, probably my profile will not look very intimidating. But so I was born and brought up in Puttur, which is very close to Coorg. And I did all my schooling here, and then moved to Bangalore and graduated from RV College of Engineering, again in the electronics background. That's the beauty of it, right? If you are into problem solving and interested in some of these computer science related topics, then it doesn't matter which stream you graduated from, you always end up in where you want to be. So yeah, after joining Ribbon back in 2012, it's been almost 9 to 10 years on job here, and have seen the transitions firsthand, not to the extent of what Gautam saw, but right from having some hardware machines, right, similar to your personal computers, which was our flagship product earlier. From there, virtualizing all that into the cloud space, and from there, very recently, again moving a step further and containerizing everything, right? That's the microservice part. So we have seen this journey, right? So, and even during our office time, free time, we keep discussing. There's a lot of transition happening in the industry, and I'm sure even in the academia, right, all these concepts are getting incorporated and getting taught. But is there something you can call it Aliluseve or squirrel service, because we all came back from the college, right? So it's our duty to give it back also. So we were thinking, how can we help you guys to and sorry, by the way, after getting into the industry, there is no more sirs and madams, and we all we all talk in a not so formal way. So we take the anticipatory bail on that if we say any of these things, right? Yeah. So yeah, so we were just thinking, how can we help from our end, so that you can guide the students. You can basically analyze and take our inputs and see what fits well and what doesn't, because we are nobody to teach, we are nobody to tell how to teach, right? We are not even qualified for that. So it's purely based on our observations and experience dealing with the freshers. So that is a main motive behind joining this session. And as for my interest, madam earlier told a bit of music, and even in the work areas, worked on the cloud computing, security. That was one of the topics which was in my mind as well, because I think we have the blockchain topic coming up. So that would be the security PKI, right? That would be a very good platform or foundation effort, but we'll see, I mean, depending on the time. So yeah, that's about myself, and probably we can talk a bit about our company, Gautam, and then get into the agenda.
Yeah, sure. Thanks, Dhananjay. And
sir, it's been a pleasure attending your session, sir. Thank you.
Thank you. Really appreciate it.
Yep.
Just FYI for everyone, Dhananjay joined our company, Ribbon Communications, at that time Sonus Networks, as fresher. Okay, and he's with us for more than close to 10 years, and I'm with Ribbon for about 15 years now. And yeah, all along we have been working very closely, very young, very young and energetic, and innovative, I would say. Okay, yeah. So a few words about Ribbon Communications. I have if I have to guess, most likely most of you haven't heard about Ribbon Communications, but likely some of you looked up on Google and found who we are. Okay, so just want to say a few words about our company. Our company is a multinational. Our headquarters is in Texas, US. We are about 4,000 people company, and Bangalore is the largest R&D center of our company. And happy to say that we are part of that and leading some of the technologies. We are into voice over IP and 5G, and real-time communications. Say, for example, this call, the Zoom call that we're talking on, we're all on, and we have been using for for last couple of days and more. It is very likely this call is going through one of our systems in the backend. So we are the ones. The products that Ribbon Communications builds are some of the products that drives this innovation and real-time communications behind the scenes. So that's why most likely, since we are not end user touching company, not as many people heard about Zoom and Google Talk and all those things. Probably we are not as popular, but we are the power horses behind the scenes. Okay? We hire about 50 to 100 freshers every year from various colleges. We go to some campus selections as well, and then many laterals. When I say laterals, it is experienced people. And this year alone, in spite of all the pandemic and remote working and everything, we hired more than 500 people into our company. So we are into growth, and this pandemic increased the demand for our products as well. One example I want to cite there. One of our long-term, the customer, bandwidth.com, they are in the South America. They were using our hardware solutions for a long time, and we were planning to move them to cloud. They said, no, cloud won't scale it. We don't want it. But guess what? The pandemic hit, the demand increased. Immediately they said, oh, could you please tell us about your cloud solution? We remember you telling us. And there we go. We were able to make some really big sales there. Okay. In addition to that, any of the big telcos that you can imagine across the world, they are all our customers. For example, Verizon's, AT&T, British Telecom, Jio here. Jio is one of our large customers. Okay, and Singapore Telecom, Australia, Japan, KDDI, the Olympics, the network that was built for communication to the Olympics, that was built on top of our products. Sure, little bit disclosure there. Ours is not the only product that was driving the entire Olympics, but it is a key element of the network that they have built for all the communication needs and Olympics Village and so on. Okay, so that is about briefly about Ribbon. And it's pretty exciting company. A lot happens technology point of view, and we lead a lot of new technologies as well. Okay, so with that, I'll get into agenda. Okay. So this is our today's agenda. As I said, we at a very broad level, we split this as 3 parts. The purpose of our talk itself, we'll spend a few minutes just so that we get the context. And then we'll jump into history of cloud computing, what is cloud made of. Okay, so various topics you see there, and how a typical new technology adoption looks like, and why that matters to the academia, the educational institutions like all of yours. Okay, and who are the big players in this space? What are the how the evolution looked like, right? From the hardware-based data centers to cloud computing. And you must have heard a lot about this X as a service, everything from infrastructure to platform to software as a service. And nowadays we are hearing as food as a service also with Zomato's and Swiggy's. And then some examples we will give. And another interesting topic is microservices. So while the cloud is a platform, microservices tells us how to solve any real life problem using microservices. Hope we don't overload you with a lot of information, but we'll be happy to pause at any point in time and take questions, because we have a very high breadth of topics to cover here. Post your questions on the chart, and one of us, either Dhananjay or myself, will keep looking, and we will try to answer as the questions are getting posted. So feel free to interrupt and unmute yourself. If it is a discussion, that's the best I could wish for. And then what are the next steps, and some certifications and key takeaways, and what is our recommendation? So, as you might have realized by now, we are the technologists, we are not the teachers, right? So, but at the same time, we'll try to give some hints at probably based on our understanding. At some point, we are students, right? So based on our understanding and based on what we saw from freshers, what is it that we would recommend? Okay. Okay, let's jump into that. So what is the purpose of our talk, right? As I said, we have been hiring continuously for every year, and we are growing. So what do we see when we are hiring any freshers, right? Problem solving skills, as Aman talked about. Aman was our colleague until earlier this year, until he moved to Google. But problem solving skills, obviously. And what are the technologies that you have learned? Typically, what we check for is whatever the student claims they have learned, do they really know? Okay, so it is important to really make the student feel confident about what they are learning, and go that extra mile to make sure that they really understand, they question the things, they really get the gist of it, right? And more importantly, willingness to learn and explore. This is not an easy thing to gauge for us, but we do try and we do discuss. When we interview people, we do discuss this and say what do you think? So, okay, they may not be up to speed on some of the latest technologies, but can they learn? Okay, so, and this attempt is really to make you all aware that this is what typically industry looks for. Okay, and now coming to the academia, right? It's a classic question that academia should lead or catch up. Okay, so sometimes we may see lead really, because that is where the big brains are at work, and they have the time, usually have the resources. But at this point, I want to digress a little bit and tell one of my stories. Right? When I was in US, I attended I took a couple of courses from Harvard University, one of the prestigious, and it was an eye-opener for me. Okay? So the way the teaching happens, the way they collaborate, it is almost never a lecture. It is always a discussion, debate. Okay, and when they come to the class never starts with a very specific topic. Sure, they have a topic in mind, they will cover that, but sometimes they reserve for what is happening on that day. For example, a 5G news happened here. Okay, a 5G new thing happened in the last 1 week. They would discuss that, they would debate that. So that really opens up. So that is truly eye-opener. I mean, having did all my education in in India, where it is more of a still bit of a traditional education, I would say. Two, it's more like lecturer is treated as a peer there. Okay, and they are open to challenge the professors. And even more important thing there is, when I was taking these classes, there are two professors, actually two persons. One is a professor from the pure academia research background. The other one is an industry veteran. He's a CEO of company. He ran multiple companies. So those two, in a collaborative way, were giving those lectures. So it's an excellent mix of industry and academia, right? So that is what kind of drives us to, that's our purpose. Can we, if not exactly lead, can we try to implement something similar here? Can we build that bridge between the gap between the industry and academia? Okay. So yesterday when Kalal Venkat and Dr. Suresh Kumar, Sri Beliapa, when they were talking about, the rural colleges are struggling to survive, Whereas on the other hand, industry is surviving to get the right talent. That really hurts, right? So two people are struggling. One person, on one side, they are struggling to show the relevance of themselves, that is, college in rural area. On the other side, people are, industry is struggling to find the right candidates. So there is clearly a gap there. I hope you all agree with me, right? So this is a sincere attempt to bridge that gap and whatever little impact that we can make. Okay, and yeah, that brings us to help you to help us. It's really win-win. It's not a zero-sum game. It's true win-win opportunity there, right? And this is another point that I would like to highlight: researchers versus design and develop, right? So when we say, in academics, some kids, some students are interested in research, like many of you, right? They want to do the real core research. That's great. That's what creates innovation, leadership. And a good majority would like to design and develop. Okay, our focus here as part of this talk is going to be design and develop, not so much of researchers, right? Because honestly, we are not even qualified to do that. Okay, so what we can do is what industry looks for in the design and develop, and that is 90% of the population, or maybe 95% of the population, because research happens at the very premium core, some institutions and academics, and industry adopts that and moves forward. Okay, and this topic came up in yesterday's keynote speak also. Interdisciplinary, and give the big picture. Okay, so typically what we see when we are talking to the candidates is when we ask a question about let's say C++, or Java, or whatever they claim they know, right? They put in their resume. When we talk about that, typically it comes out as, sir, I did that 2 years back during my second year first sem. Okay, I get that. But these languages should not be treated as subjects. This technology should not be just treated as subject. Sure, there is subject. It's a subject, of course. But it should not be just a subject and exam is done and you move on, right? So these students should be learning to build solutions, to build what industry is looking for, what society is looking for. Say, for example, there are so many startups here, right? Unicorns, multi-billion-dollar startups. So how are they happening? We don't expect all the kids to build the unicorns right away, but still, they should be able to be ready to work in those unicorns at least. Okay, and here is an example, right? Once the database course is done, they shouldn't be done with it really. When they're learning data structures and algorithms in the next one, probably they should apply this one there. And similarly, both of these should be applied during the web designing course, right? How you use the databases, how you use the data structures and algorithms to solve the problems and make the performance improvements and so on. Okay. And in this attempt, we will show some examples of we will propose few things like how you can use the cloud computing for running all of your projects right from day one, right from get-go. Okay, right. I see one chart there. Anything that I need to? Okay, yeah, thanks. All right, so now jumping into the subject itself. Dhananjay, feel free to interrupt me if I miss any points or if you want to add anything anywhere. Okay.
Yeah, sure. Just one thing. Just wanted to add. So this was set up for like 3 hours, right? So we were wondering, what do we? It's not more about what do we talk for 3 hours. We can keep on going, but what would happen to the audience, right? Because sitting straight for 3 hours, then we remembered our good old college days where we used to have special classes and all those extra hours. So we thought, yeah, this is the revenge time now. So just kidding. So yeah, surely we will be done before 3 hours, and the focus will be more on quality than quantity, right? We don't want to fill up 3 hours with some inputs. We want to give the specific inputs which we think are relevant, so that you can analyze and take whichever you think is feasible and good to incorporate. Okay. Yep.
Okay. Hey, while we are on that topic, Dr. Sharma is asking, with universities' fixed curriculum, how to train students behind syllabus. Excellent question, sir. Here is what I would say, right? I would like to give an example, the first-hand example, right, that I can see. It's what one of our team members, Sayan, his name, he joined from VIT Vellore about 2.5 years back. Guess what? He's from biotech background, okay? But he explored a lot of things by himself. Like, some of the things that he mentioned, we were just exploring, or we didn't even know sometimes, some cases. So that's an example. But the point I want to make here is, it's a classic, there are three things: time, money, and energy, right? Any point in life, we have only two of them, usually, like, by and large, for majority of us. If you guess, students have time and energy, okay? Not so much of financially well off and so on, but time and energy, definitely they will have, okay? So as educators, what I feel appropriate is to give them the leads, encourage them, show them the path, cut them loose. This is not part of the curriculum, but if your universities, of course, you need to work on, you need to work on some, frame of work and all that. But if there is an opportunity, just introduce some of these things to them and cut them loose. And if they are interested, conduct some seminars or, weekend, discussions, debates, and those kind of things. So this definitely has to go beyond the set curriculum, no doubt about that. Okay. Hope that helps, but I understand the constraints that the academy also works in. So appreciate that question. Okay, thanks for that question, and people keep posting, and we'll check after maybe every slide or so. Okay. So software as a service, you must have heard about this a lot, and Salesforce.com is one of the pioneers there, and it's a multi-billion dollar company now. Must have heard about that. And they use at that time it was all data centers, private cloud, but that is when the first time kind of they introduced it. Okay. And then various search engines. Some of you must have seen that, everything from Yahoo to Alta Vista to I even forgot what was there. This is pre-Google era. Okay, and that is in the private cloud. Okay. Again, I keep throwing these, some of my experiences there. About this came back from a search. Sorry. About 7-8 years back or so, when Dhananjay joined our team, when in a casual talk, I was mentioning at the time when Google was not there, we used to search in the books and all that. He I still remember his expression. He was of what do you mean by Google was not there? Google should be there forever, right? Without that, what do you do, right? But just see what happened in those just 2 decades, and what enabled that. It started off with the private cloud, and it moved on to public cloud. Okay, and that is what we're going to cover. And earlier, personal computing was, as I said, a dream, and it was not there, not generally available. But nowadays, every home has multiple personal computers, if you include your phones and Alexas and Google Homes and whatnot, right? So this created the demand for the content and services, various services, right? Once you have your device, people want to stream, be it Netflix, be it Hotstar, or for that matter, the food companies and Amazons and e-commerce and whatnot. Earlier technology. So this is an interesting thing that is so relevant to this entire audience, that is comp science and engineering background. If you look at any earlier innovations or revolutions, right? Once it is innovated, it used to take generations for it to be getting adopted to other geographies. Say, for example, electricity. That's one of the greatest innovations, no doubt about that, right? But how long did it took to spread to every corner of the world? It is still not there, right? Similarly, if you consider train system or irrigation system, any of the earlier technologies, right? It used to take generations to penetrate to the lowest level, whereas our field, computers, IT is such an exception. That's why we see so much of transformation within one generation, right? So it started off somewhere in 90s, started taking off in early 2000. In 2020s, it is everywhere. We don't even need to be physically in one place to do the best communication that we want to, right? So this is the enabler. This is the power of the field we are in, right? So that it's important to put that in perspective to see what magic it can do, the idea, what the ideas can drive, right? And what enabled all of this, right? Global fiber optics. Okay, I'm happy to say ribbon communications is some part of that. And it is, the infrastructure that these big telcos built, undersea cables, optics, and that's in the late 90s that happened, that revolution. Okay, and here is an interesting fact, right? Netflix, I'm pretty sure all of you heard about. It used to ship DVDs, believe it or not. I subscribed to these DVDs when back there. Okay, and they mail you as in post you watch, you post it back, they send you a next DVD that is in New York. In 2007, not so long back, they shipped their billionth DVD. Okay, and exactly that year, they said, okay, we will slowly deprecate DVD and go to the streaming. Just think about what's the kind of, the innovation, the confidence, and the foresight they need to make that decision that whatever business that is thriving, they want to say, okay, this reached the peak, this will go down, let's switch to streaming. That's exactly what enabled the cloud computing. Because around the same time, AWS started, Amazon Web Services, that's what we are going to talk about more. And Netflix, even to date, is the largest user of AWS. So entire Netflix movies that we watch, the documentary series that we watch, everything is running on AWS cloud. Okay, and that is how they could scale, and they could scale so fast. When they want to extend their presence to, say India or any other countries, it's a matter of tying up with AWS and designing the systems around it, and then putting the content there, and of course legal and all those frameworks will be there. But that is the power of cloud, how fast you can move. Okay? Then what enabled a lot of these are, day to day we use cloud everything, right? When we talk about this Zoom or Google sharing any documents or anything, that's all on the cloud. And here are other things, right? Banking and government companies. And for example, tax filing, pretty sure by end of this month, we all need to file the taxes. And where do you go? You go to IT section, most likely that's running on the cloud, some cloud. Okay? And more importantly, as I said, tax season, scaling on demand, right? We'll talk a bit more about it in the later slides. But the key here is, it's not always in demand, right? Whatever infrastructure that you build, it's not always needed. For example, Netflix, guess what? During the weekdays, it may be running at 30–40% of its capacity. Weekends, obviously, it will be more. And even better example, when the IPL matches are there, or matches between India and Pakistan, of course, there'll be huge demand on the Hotstar now, right? So how are they scaling? End user without seeing a single glitch. Of course, sometimes very rarely buffers, but Hotstar did a wonderful job of doing their homework and scaling really. So that is what cloud enables. And when nothing is going on, Hotstar servers must be sitting idle. But if they are using cloud, it won't be sitting idle. It will be used for some other purpose. Okay. And same with the Amazon sales and such. So in this area, on-demand computing and storage, as we're going to see, AWS is the leader. Okay. Some of you must have heard about this excess capacity in Amazon, that they have to build during the sales time, and they started reselling that capacity in the computing and storage. But I read an article from the CTO of Amazon, AWS. He said that is a myth. It was never like selling excess capacity. They saw the opportunity because their IT department built their networks, and then they saw the opportunity to say, oh, okay, so maybe what if we build similar infrastructure for the entire world? So that's what an idea can do. Okay. All right. So I'll move to the next slide. Oops. Okay. Just before that. Okay, glad to hear that. Thank you. Dhananjay, that's for you. Revenge is turning into knowledge. Good. All right. What is, so, too much of serious, little bit of serious talk. So let's see. Just like when I say Apple, what comes to mind? I'm pretty sure if I have to take a poll, at least good 30, 40, 50, if not more percentage would say that's a premium phone company, right? So similarly, to our kids, for sure, next generation, when we say cloud, we have to think twice, like, which cloud is the kid talking about? The one over there up or one that is I'm using day in, day out, right? So what is it made of, right? It is largely Linux servers, okay? By and large, it is Linux went into such an extent that even Windows adopted Linux subsystem on their OS. So on Windows 10, for example, if you see, there is WSL, Windows Subsystem for Linux. So earlier they used to fight with Linux, but then they thought, okay, Linux backend and server, when it gets to servers, we can't compete because Linux clearly has an advantage in the ecosystem there. Where Windows thrives is user interfaces and end computing and PCs and such. So it's the game over, right? So why I'm mentioning this is such an important thing, right? Because when we talk to students that are coming out of college, majority of them rarely use Linux or little bit exposure, not much. But our take is everybody should be using Linux day in, day out for all their projects, for all their work, okay? And that enables them to get onto the cloud. It's not difficult. We can help if at all needed, right? But once you get those initial leads to them, right? So I'm pretty sure, may not be 100%, but majority of them will quickly learn and adopt and start enjoying that, right? Because they have, most of the cases, they have time. And the other one is this is another famous one. The naysayers of cloud usually say, no, cloud is there, but it is just someone else's computer. It's not a real thing, right? But no, they are proven wrong already, and it is everywhere. But as we're going to see in the next slide, understanding the computer is extremely important. But at the same time, you need to have the power. You need to understand what a true cloud computing can do. Okay, so then moving on to the next slide. Okay. All right, so how to understand this cloud better? Right? So to understand the cloud better, first of all, you need to understand what a computer is made of. Okay, because essentially it's the same components that were put together by some big companies to be used by multiple, anybody in the world. Let me put it that way, right? So it is essentially the similar building blocks and a lot more. We will touch what are those lot more, but at the gist of it, what is it that we have? Right? A CPU, RAM, disks, and some devices, be it cameras or microphones, speakers, and whatnot. Right? Sure, when it gets to cloud computing, you don't need these the multimedia disks, but it is a computing power that you need. CPUs, RAMs, disks, and so the gap that we are typically seeing is, with the laptops, you don't get as much exposure. When I say you, the students don't get as much exposure as they would if they were to build their own PCs. Right? The candidate that I mentioned, Sayan, he builds the computers by himself. Right? So similarly, these guys can educate their peers. They can share their knowledge, and together they can start a journey towards the cloud. Okay, so and within there, what do we have? Of course, at the top level, software we have. That's what everybody sees and uses, and usually it is a double click. And underneath, there's a OS kernel. I don't need to teach you about that. And then that is what is controlling all these various things. right? CPUs, memory, disks, and devices. But it is important to make the students understand cloud computing is not somewhere, some magic sitting somewhere. Right? It is the exact similar to, you can draw parallel to your PC or laptop, a whole bunch of those, thousands of those sitting at a global location. Okay, and anybody can access it. That's it, really. Like, if you have to explain in simple terms, that's all it is. Okay, everything else is pretty much details. Okay. Dhananjay, have anything to add here? Or
Yeah, I mean, so you're spot on that. We think that by, because this is what we also did, right? Before we got to and understood what cloud is, understanding the computer better was definitely helped us. And probably in our era, it was easier because we had those, doomed computers where if you have to upgrade your RAM, you have to, take it out by yourself, order a new RAM or, few new blocks and put it by yourself, right? But nowadays, since everyone is using those slim and slick laptops, they may not know what is there inside those laptops, right? Except that when they press the power button, they see a nice window popping up. So I think it will be good. Probably a key takeaway I would say for everyone from this slide would be to convey to the students that understanding your computer, how it works, and also Linux, right, is very essential, not just in the cloud space, but in general in industry, because I think probably more than 80% of the industry uses Linux in general. So a good understanding of that would really go a long way once they, they are out of college and start their career in the industry. Yep.
Right. Yeah. Thanks, Sanjay. Yeah, there was a question why it is called cloud. Honestly, I don't know, but I have to guess only. Maybe because it's everywhere. Because it's, if anybody knows better answer, feel free to share in this forum. Right? We'll be happy to learn. Okay. Yeah, or post there. It's an interesting question. Yeah.
Maybe it's like the general, cloud which is moving and
Changing tips.
right. It's remote basically.
Right,
so
right. Yeah. Could be. So yeah, some innovators coin those terms and it sticks a lot of time. Right? And another question: distributed computing and cloud computing are same. So distributed computing you could do in your data centers or in your labs, or together if we link bunch of our computers. Say for example, we have 4 friends and 4 laptops tied with a LAN, and then now you want to do distributed computing, you want to do some data mining and analysis, right? Then what you can do is get the data, spread it to all 4 laptops, make them work, and then report back the answer, right? And then it will be, one guy will consolidate, one laptop will consolidate, right? So that is distributed. So what I would say is distributed computing is used heavily in cloud, but they are not one and same. Okay. Right. So hope that answered that. And yeah, technology adoption. This is an interesting curve. I don't know how many times I looked at this in various contexts. The key here is every technologies keeps coming from the left side. Cloud computing is not end of it. It is only the beginning of the journey, and journey is going to continue forever. Innovations are going to happen, right? So the new technologies keeps coming here, and that is done by about 2.5% of the entire population. So innovators are about 2.5%. Great, big thanks to them, right? And then there will be some early adopters. If you ask me, Netflix is one of the early adopters, right? So they are ready to experiment. If they failed, they feel it's okay, we'll fail, but we'll learn from it and we'll move on, and they see the potential of these new technologies. So they adopt. And getting it to masses, getting it to volume, always has this charm. Okay, so a lot of technologies can't cross this charm and get to the mass public, but that's okay. And this is where the research plays such a huge role. Okay, so this is where the researchers are. This is where the academia, by and large is. Okay, but that is a small percentage. But what industry looks for is these two segments, early majority and late majority, where the adopters, because of the industry they are in for various reasons. Some companies adopt here, some companies are the individuals for that matter also adopt here. You know what is fascinating about this curve is you can apply this to a lot of things. If you look at any new app comes up, new technology comes up, right? You see some people adapt to that very quickly. Like for example, OTTs, right? When we say like OTTs, Hotstar, or like watching movie in Hotstar versus having plain old cable connection, right? So that OTT, there will be always early adopters, right? So, and they have that power too. And if they can help these majority folks, that will really help. Okay. And what I want to mention here is in your colleges, in your classrooms, how are the technologies fitting in this curve? Are you catching up early? Are you catching up along with the early majority, or all the way are we lagging? So this gives a framework for you to think about, say, cloud computing. If you say cloud computing, I would say we are in the kind of like somewhere in between early to late majority. It's a new platform, right? And for each of your student and classroom, right? So are we here? If we are here for the industry, we are relevant. Learn those technologies for sure. If we are lagging, we are struggling to find a job, and on the job, definitely people, we have seen so many freshers, they all learn, right? Only thing is we want to push that learning little bit to the left side so that one, they feel excited, they are happy, and they can help their peers, and the entire ecosystem can build around it, right? And industry don't need to teach them that, right? Industry can focus on delivering their things, and academy, more and more new technologies can get adopted from the academia, and that really enables not only like if the industry will look up to the academia to give the guidance, right? So that is what like the long-term goal should be. But this gives a framework for you to think about what are the technologies in this space, right? And are we up to speed on that in our classrooms? So that is one thing. And cloud, as I said, is somewhere in between here. Sorry, there was somebody talking. Any question there? Okay. All right. So here is a fact, right? A little disclosure. These are not the diagrams that I drew or that they drew. These came, we picked up from internet, from various sources. Little disclaimer. Okay. Some of these we drew, but like good number of these we picked up. This is from a Gartner report, which is a very famous like technology. Which technology is where? What they keep publishing every monthly or so reports. Their annual report is usually pretty good. So out of all the organizations that are using cloud, 75% of the organizations or the companies have the cloud first strategy. What does that mean? It's an important keyword, right? If they have to, let's say this organization want to deploy a new app in their organization, be it new email app or new charting app, right? To collaborate. Their first thinking, earlier they used to get that software, their IT department will install in their servers in-house and then provide the service to employees, right? But now they are questioning that and saying, why not start with cloud first strategy, right? Don't even think about get the software and install in your boxes which are sitting in your area, right? Okay. Okay. Yeah, that is that. And what are the obstacles in integration? Yeah, okay, we'll come to this topic in a bit. Okay. Just wanted to check how we are doing on time. I think we are still okay, but may pace up a little bit, but feel free to stop if you have questions. Okay. Yeah, the big players in the market share. Okay. Amazon leads this space, 32% of market share. Okay. Azure from Microsoft is a little bit behind them, not really a little bit, but they are a little bit late to the game. And Google Cloud is even further down, but each one of these are used by some big companies. Okay. For example, AWS, Netflix, Azure, I believe, like, federal government, US federal government, and some of the Walmart, I think probably Google Cloud. So, and then Google servers themselves are running there. And then there are some smaller players, Alibaba Cloud, IBM, and Oracle. Seems like Oracle is having some decent success recently. Okay. And coming to this side, right, let me just move that a bit. Yeah. Some statistics here. I'm not going to go through each one of those, but some interesting statistics. 94% of all enterprises use cloud services. Okay. I don't know which 6% are still not using, but definitely they must be already there since that report came out. Okay. And earlier, the challenge for the organizations is used to be, any sensitive data we can't store on cloud because because of security and regulation reasons. That is changing quite a bit. As you can see, it's almost the halfway mark. Once it reaches halfway mark, it will catch up in no time. Okay? And some of these, issues that comes up in the cloud, security related things, mostly those are because of not lack of technology, but incorrect implementation of humans by humans, right? And then, we have this is an interesting. By 2025. 100 zettabytes of data will be in the cloud. Just imagine, zettabyte is 1 billion terabytes or 1 trillion gigabytes. So much of data is getting there, and people will be analyzing that data. Right? So that's a lot. Okay. So what are the use cases very quickly? Okay. There are things like always up and running at certain capacity, right? For example, CIT's website, right? Or any of your college's website. Usually don't need it, the capacity or the demand for that won't be changing that often. So these are the small web servers. Then scale on demand, shopping, media streaming, as I mentioned, when the demand needs, they need to automatically scale. Nobody need to be there physically to scale up, scale down. And cloud enables that. Then batch processing, for example, every month end or weekend or yearly processing, that is another use case. So for each of these things, there are something called services that we have that we're going to go through. Okay? And then trigger based, right? So let's say you took a picture and you upload it to your Google Drive, right? Immediately you can set up a trigger in the cloud saying that whenever an image is uploaded to my storage space, you run some refining algorithm there or posting it to somebody. You can run those kind of algorithms in trigger based. So it comes as soon as you upload, it does something, it goes away. Okay. Then analytics, we all know, it is similar to batch, but very high storage and processing intensive. Then best effort processing. They're not really, can't cite any good examples that we all can relate, but there is that thing as well in the cloud. And then at rest data. Say, for example, you took some videos 5 years back and uploaded it to cloud, right? And that should not cause much cost, obviously, right? So at rest data, which means that you may not be accessing that every day, but it should be there. So that is cheaper price. Okay. All right. And yeah, now getting into the cloud, data centers and how the transformation happened. So servers, obviously that is a computing power, we all know. And storage, this is network-based high availability storage, right? So this is if you have NFS or NAS, network access storage, that's what this is. And network itself need to be built for interconnecting. This is similar to your LAN in your colleges also. And then of course, applications that runs on top of that, whether it is web app or your email app or anything of that sort, right? Power and cooling. So when anybody builds their own data centers, power and cooling is one key element. Whereas when it started evolving from personal or private data centers to public data centers, the first step that happened was this thing, virtualization. Okay. And instead of using the hardware as hardware, using the proprietary hardware from Dell and HP and those kind of things, use the generic servers and you do the virtualization. Okay. And then on-demand computing, talked about that enough, right? Infrastructure you get from cloud, right? On-demand computing as in when you need scale. when you need to run some batch processing. And here are the advantages, right? Once you start using cloud, you don't need to know anything much about hardware. Sure, for some minority of researchers or computer science students who are working close to hardware, they need to have hardware, no doubt. But for the majority, they don't care what hardware it is running on. As long as their program is running, whatever they developed, it is good. And effective use of resources, right? Let's think about if Hotstar were to develop this big storage, like big private data center. And when IPL is not going on, what do they do with all those hardware resources? Goes waste, right? And instead of that, they will be using, if they use cloud, they can scale up on demand and scale down and don't pay, and pay only for what the servers and services that they are using. Okay? And then efficient operations. And because very few experts will be building and managing this, you don't need to build expertise, fragmented and not so up to mark expertise everywhere across the companies. Okay? And as I said, some of the challenges are data security and legal things, but those are getting addressed pretty fast now. It's no longer really a concern. All right. So here is the gist of it, right? X as a service. Right? So as discussed in the previous slide, it moves from on-premise to the cloud. And as they're making this transition, right, from networking, so in any data center, if you see, it needs all these layers, everything from networking, storage, and then the servers itself, and then virtualization platforms, middleware, and then only comes the application. You can run the application. But most of the people need to work in these two top areas, application and database. Right? How do we do that? Right? For everybody, instead of setting up this, slowly start moving to right. Right? If you need infrastructure as a service, what it means is, on the right side, as I mentioned, dedicated hardware or VMs you get. So they provide you up till this layer, from networking to virtualization only, and operating system and everything above that you bring in. Right? You as in the user brings in, a student can bring in if they need this model. Right? Whereas the PaaS is platform as a service. Right? So in this case, OS also is provided by cloud. Middleware, that is mostly for communication, timers, if you in your software, if you need timers, all of that, and the runtime, say JRE, Java runtime environment, and those are provided by runtime here. And you come up with only application and data. So we see that students can definitely do development in this area most of the times, most of the comp science students. Some in this area, almost no one in this area. But we should still encourage students to do in this area because that enables the learning also, right? So because they will be building everything from down. But they need to be aware of you don't need to build all of this for efficiency reasons, and instead use these services from cloud. Okay. And software as service is pretty much the Zoom. We are not doing any development. We are just the users in this layer here. Right? The lead code that Aman mentioned earlier, or you can give Gmail. You can give plenty of examples there. Right? Okay. So just 1 second. Yeah. So hope this chart is clear, because this is the gist of cloud computing, right? On-premise, what all you need to do. If you're using infrastructure as service, what you get. Platform as service, what you get from cloud provider. SaaS is pretty much user, not really any developer. Yeah. Okay. So there are a couple of questions. We'll take those. Distributed computing, we have answered that. Obstacles in the integration of technology in education. Yeah, I said we'll come to that part. For data centers, what physical and logical security measures are in place? Good question. So there are various things at various layers, right? So the security starts with the firewall. Okay. So as we are going to see in one of the next slides, we will never expose our actual apps directly to the public. There is always some security devices in between. So firewall is the first starting point. And then recently what they are doing is any packets that are coming into the cloud, there are services to send every single packet, IP packet, into a service that checks for some patterns and intelligent algorithms to decide whether this packet is good or bad. Okay, if it is bad, it drops. If it thinks it is bad, it drops and reports. If it is good, it forward to the right application. Okay? So there are at hardware level, that's mostly the firewalls, and at the software level in terms of load balancers and these security applications. Okay. All right, so moving on to the next one, there was one more question, sorry. What technology available to learn cloud computing? It needs any hardware tools? Excellent question. We'll come to that. Just hold off your question, sir. We gave enough links at the end, towards the end. We are just getting into that. Okay. So example services provided by AWS. I mean, something similar services are there for GCP, Azure, and all the standard providers, but they're all with a different name. Okay. So here are the examples, right? When you say EC2, Elastic Computing version 2, this is a computing platform. This is just like your CPU, memory, and disk is what you get. It's essentially a Linux server. And what, I'm not exaggerating at all if I say I can have my own Linux server in next 5 minutes, maybe even 2 minutes. Okay, if I switch to my web browser and go log into my AWS account and Linux server, in less than 5 minutes, I can have a Linux server running. So now it is, I mean, sometimes that baffles us, right? Like, why students should be aware of this, and they should be using this more and more, so that when we talk to them, we talk the next level questions, not really about the Linux anymore. Right? And similarly, databases, for example, MySQL is provided. S3 is a simple storage service from AWS. You can store documents, images, video, whatever you want, right? That is a storage. It's a name given by AWS for various components. And these are all the services. In their terminology, it is called services. But if you were to map to PC or laptop, as Dhananjay mentioned, you can clearly draw this mapping, right? And VPN. So this is more like a LAN that you connect to. Okay, that's just like colleges network and any LAN. Notification service, right? To send mails when you get an OTP, when you log into your bank account and transferring some money, right? That's exactly what is in work. Notification service. Okay? And then serverless computing. Okay. Serverless computing is an interesting one. As I said, the bad job, as soon as you upload an image to your storage, that is S3, you can set up Lambda saying that, hey, run this algorithm to refine that image or share with my friends. There we go. So now you know how that works behind the scenes. Right? And the scaling, we talked about this, and Hotstar, I almost became advertising the Hotstar now. And yeah, scaling up and down. IAM is another service that is like, user creation, logins, permissions, authentication, that pretty standard. Load balancing, we are going to see this as an example. There is no easy way to explain this, but once you see the next diagram, you can connect. Okay. And Route 53, domain name servers, when you type in name in your web browser or anywhere within your program, for example, that need to ultimately get resolved to IP. So that is called Route 53 service from AWS. There are similar services provided by multiple other people, okay? Other providers as well. Right. So, yeah, there was questions of what is the AWS technology, how it is used. Okay. So, yeah, we'll show that in the next diagram. Right. So here is one big picture, how AWS is used, for example, right? So let's say your college website is there. Your college website can be hosted in any of these servers. Okay. And this entire thing is running in the AWS. Okay. This is the user, your laptop or mobile app or PC. And when they type a URL that goes to DNS, your laptop really goes to DNS and looks up, hey, mywebsite.com is mapped to this IP. Okay, now let's go to that IP. Routing happens, that's a public IP. And load balancer, that is what is provided by AWS. Okay, and behind the scenes, actually your web app, that is your site, is running. When I say web app, that is your website is running. Okay, and this load balancer will distribute the load among these two. Or they can be many, there are thousands really. In real life, it can be one, it can be thousands. Okay? And why do we need thousands? Scaling, that's exactly what is scaling. as the demand increases, let's say your website became very popular and a lot of people are accessing that at some point, you can configure the AWS to show, to say as the load increases, automatically launch more servers for me with that particular, your website code. Okay, and the load balancer automatically will start distributing to them. So magic, it's almost like magic. And when the load decreases, you can set the some metrics saying that if the load is less than so and so, scale back. Now you are not paying that much money. Right? So this is the power. So when I say load balancer, this is what it does. Another great advantage of load balancer is, let's say your your website is up and running, and you want to completely change your website settings and completely revamp it, and you want to roll out, right? And you, instead of updating it on both and running into bugs and issues, you can just update it on only one of the servers and see how that goes. Okay, if it is all looking good, then you can upgrade here also, put the new website here also. If it is not looking good, bring it back to the old code. Right? So you're not entirely taking the website down. You are just, in a more cautious way rolling out the things. Okay, hope that answers the question.
Yep. Just one thing I want to add. So if it is not clear, I'm sure it must be, but load here really means, number of people who are accessing your website, right? So, yeah, currently, let's take example of this session going on and people are interested to see what CIT is up to, right? So they want to check the website. So there may be, 10 people viewing your website, but let's say tomorrow, or let's take some other example, Amazon, not CIT, and the fest is going on, right? The Amazon, the grand sale fest. So instead of 10 people who usually log in and check out things at a time, there may be thousands of people logging in at a time, right? So your server one, which has the Amazon website, might be already overloaded and it can't, respond to the incoming requests. So what do? You put the, same host the same site on one more server. So basically these are crude examples. It may not be working this exactly same way, but this is so that we understand better, right? So now if the Amazon has its website copies on, let's say 10 of these servers, right? Server 1, server 2, and 3, 4, up to 10. And even if there are, let's say 10,000 people logging in at the same time. So what the load balancer will do, so it will distribute the load in such a way that server 1 will get these many number of people, and server 2 will respond to these many people, and so on. So that is maybe a crude example, but just in case if anyone didn't get what the load balancer does. So thought of explaining.
Sure. Yeah. Thanks, Dhananjay. That helps. Okay. So if this is the first time for any of you looking into any of these terms and also AWS in general, this may be a bit overwhelming, but it is really easy. And if needed, we can have kind of a working session to show what you can do, right from setting up an account to launching your own website, even if that says hello and your name, right? As simple as that. That's a website. You can access it. Anybody in the world can access it. And you can set up that in less than half a day. Believe me, I'm not lying. Okay, so it is really that simple. This entire cloud made it so simple. Okay, so that why they made it, the advantage now is you don't need to worry about setting up of these servers. What is the hardware? What is the Apache server running? What is the HTTP? And what is my public IP? How my friend access that? All of those are solved by cloud, so that we all can focus on the application that we want. What is that new idea or the new application that we want to build on? Okay. Yeah, moving on to the next slide. Yeah, so now we are quickly, we have seen what the cloud is made up of, servers, databases, and such, and what are these various parts, if you are using each of these as service, what comes up, and then what are the various services. And one thing I forgot to mention here is there are 300 plus such services. It is overwhelming even for us to find out what are they. But here are the most famous ones, most used ones. Okay, and to build this, the services that you need is load balancer and then EC2. This is EC2. Server is nothing but EC2. That's it. You have everything. Of course, to log into this, you need IAM and those, but nothing much. Okay. And so with these services, we can now transition into microservices. How you develop your application, the mindset, and what microservices is. Okay. So that Dhananjay will be walking us through. Okay. Yeah, Dhananjay, ready?
Yeah, sure. So, yeah, I mean, I'm sure this is a bit of an advanced topic, and not sure if in the academia if we have these subjects in the syllabus. But if we have that, that's great, definitely. So there is a concept of this microservices versus monoliths, right? So maybe we can take up the monoliths first. What is monolith, right? So uh, so if you have to say it in one sentence, so it's all in one. That is what monolith is. So for example, let's take example of we see some of the profiles like full stack developer, right? So what they do, they develop the front end, they develop the back end. For any website, let's say you're designing your college website, there will be a front end component, there will be a back end component, and there may be a database, right, to store the user details and so on. So all these, if someone is expert in developing all these, we generally call it as a full stack developer, right? So, and what used to happen earlier, right, when we didn't have microservices, so we would build all these as one, right, and then deploy it, right? And probably even in the college websites and all that may be the same case. So if there is an issue with one of the components, you have to probably replace all and see if it works or not. So basically all were connected, tightly coupled, and one cannot work without the other, that kind of a model we used to have. Now coming to microservices, which is pretty big nowadays, and all the new system design things are coming up in this microservice format. So before probably we can get into the principles of what microservice is and all, probably we can take a problem statement and walk through it, right? And see how we can relate it to the microservices and how we can apply those, right? So let's take an example. Let's say you have to design. So yeah, here some of the system design things will also come up. And again, we're not sure if those are also part of the syllabus or not, but it's nothing big. Let's say you have to develop or design a website similar to Amazon, right? So now we can take Amazon as an example. If Amazon or Flipkart as an example, and see what all things we see when we log into or when we access that page, right? Well, let's say flipkart.com. So the first thing we see is a login page, right? So there is a component, we can call it as a login component. And then once you enter, you will be provided with the list of products, right? Product catalog will be there, right? And now you can consider that as a module. So let's say login is handled by someone. Then once you enter, there will be a list of products we need to show to the user. So that is one job. And once you are in that space, right, and then you will see ads on the side also, right, depending on your previous browsing history and so on. So you can consider that as one service and call it ad service, right? And let's say you choose some products you want to buy, right, and put it in the cart. So that is again one more independent, actually in the microservice terms, it's an independent module called the cart service. And basically it so basically, yeah, there is one other thing though. So right from front end, we showed a lot of these different modules, right? Product catalog, cart, and ad service, and there are quite a few other things like recommendation service, based on your previous history or previous browsing or order history. They want to show you some of the products, right? So that is a recommendation service. And once you zero in on a product and put it in the cart, then what you have to do, you have to check out that, right? Or to buy that, there is a checkout process where you add your address and other things. So that is a checkout service. And going further from there, you have to put your addresses, and that's a probably shopping or delivery service. And then you have to obviously pay, right? Or it can be a COD or paying through UPI or net banking or so on. And that is a payment service. So this is how generally when we log into a shopping site and check out the things, this is how it will look like, right? Now imagine maybe in the older days all these things were tightly coupled. If there is an issue in, let's say, cart service, you may not even be able to log into the website itself. But with microservices, what happens is, microservices is nothing but a way of design where a complex problem, right, or a complex system, you divide into small parts and make them as code or modules that provide the specific functionality with standard interfaces. And that is a very important factor as well, right? So even in this shopping website example, as I said, you have a front end. Now you put one or two people just to develop the front end, right? And for all other services as well, product catalog or checkout or ad service, where most of your probably AI ML will come into picture, right? So for all these individual components, you assign some people, a small team, and tell them, this is your work, you do it however you want to do it, right? Make it as much better as you can, and you test it by yourself, right? Not with the entire website, only with your small module. If you can unit test it, that's what we call, with multiple of test cases, right? Let's say payment service is the one where the input is, you have to pay this much amount, and the services you might be providing are, you can pay via UPI, you can pay via net banking, and quite a few things, right? So the only job the payment service will do is it will take that as an input, how amount or whatever, and some details like card number, or redirecting it to the UPI server and some of those, and do only those things. Right now it's easy to unit test that, as in let's say you have a payment service in as a code, right, written as a binary. I mean, it's not the case in real life scenario, but for simplicity, let's take, you have a payment service.exe or payment service as a binary, which when you run with some input, right, input is amount of money, or with some card detail and so on. So you can check whether it processes the payment, whether it checks certain things like whether the account has sufficient amount or not, and so on. So this again for simplicity only. In general, in real life, we may not even be doing it that way, because there are a lot of security related controls we have to put, right? So there are companies who are specialized in this, like the I'm sure you must have seen when you do online payment, right? It says powered by or secured with this. So some of those companies are onto that. But the whole idea here is the complex problem you take, right? And you divide them into separate units, and assign people to work on those, and give the complete ownership of those modules into them. And when you integrate all together, right? Because to make a shopping website, you need all these services together. So you integrate with the standard interfaces. So some of the standard interfaces which are in use are, let's say, REST. Not sure again if it is a new term or it's already there in the academia. You can always look up and see what is REST, and it's it's nothing big. It provides a transaction-based, standardized interface to tie up these modules. And there are a lot other like gRPC or 0MQ and so on. So, I mean, that's what essentially, microservices is. It is to divide a complex problem into, small units, and which are highly maintainable and testable, which means you can take a service and you can test it, unit test it by providing test inputs, right? And then the next thing is loosely coupled. So yeah, I mean, if you give just these points, probably students may not understand what is loosely coupled or what is highly maintainable. So if we probably explain with these kind of examples, it would give them a good understanding of what these are, right? And again, independently deployable doesn't really mean you can uh, take only let's say payment service and discard the entire website and run with it. It doesn't mean that way. But let's say you have a website, right, similar to Flipkart, where all these services are present, and your payment service currently supports 3 or 4 modes of payment, right? You have UPI, you have net banking, and in that also again credit card or debit card. Now Bitcoin is a new trend, right? And hopefully if it becomes official in the coming days, you may want to add that as a new transaction or payment method, right? So how do you do that? You can't bring down the entire website, shopping website, to do that. So what you do, you take out that payment service binary code, you put support for that Bitcoin transactions, right? And then you plug it back in, because as I said, since these are using standard interfaces, and behind the scenes, these services do use something called as service discovery. So which means after you logging in to the website, let's say you're on front end and you want to interact with the cart service, right? Let's say someone, after logging in, someone selects a product and basically clicks on buy, right? And it will go to cart. So how does it go to cart? It won't be wired, obviously, right? So what the product catalog service will do is, hey, cart service, where are you? Right, and there are standard ways to do it, and that's what I call service discoveries. There are tools like etcd and so on. You can Google and find more details about those. And then the cart service will respond that, hey, I'm cart service and I'm at this IP, right? And then the product catalog service can talk to cart service on that IP, if it is a distributed if it is in a distributed network, and forward the details to the cart service, so that it will store the whatever info or whatever product the user has selected. So I mean, this is how they interact through standard interfaces like REST or gRPC and so on. And then they talk to each other through, again, something called as service discovery, right? It's not talking, it's getting to know the other service. And so this is how basically a microservice is implemented or built. And yeah, it's organized around business capabilities, probably not may not be much relevant in the academia, because in the industry what we do is there will be separate teams, right, handling separate things. So there may be a database team which takes care of only the database part, right? In this case we have mentioned cache or Redis, which is a type of database. It's an in-memory, highly efficient database. And some of these words also, right, in when your students approach for final year projects for guidance. So I think you can, it's possible that they're already, aware of MySQL or some of these databases which are in the curriculum, right? So it would be good if we can, if you can suggest them to go out of the curriculum and select some database which is not there in your curriculum, so that they learn about that also. But it's not just any database, right? For depending on the use case, there are different types of databases, right? Relational is one, and as I said, cache, it's a key value where database Redis, and depending on the use case, we can ask them to choose different databases. So it will look good on their resume also that yeah, this person has explored quite a few things outside of their curriculum, and came back with this in his resume. So his or her resume, and that will give a good impression whenever they come out of the college also. Okay, so yeah, at a high level, this is what a microservice architecture is, and the gist is, as it's written down there, it's a small unit of code or module that provides a specific functionality. Okay, in the example of website, shopping website, so it will be these small components, like front end can be one, your product catalog can be one. There is one other which is missing, which is a login service, right? We want to check if the user is logging in with right credentials or not, and depending on which user it is, we have to pull out his history, right? Browsing and order history, and give that input to the ad service so that it can show some of the ads on some of the newly arrived products, and so on. Okay, so there is a lot of science goes behind all of this, but at a high level, this is what the microservice architecture is. Okay, so yeah, I think the one on right, the GitHub link which we provided, you can encourage, since we'll be sharing this material anyways, you can encourage, and you yourself can also go through that link, and it gives a demo microservice. So it basically gives a code and some instructions on how you can deploy this example service on any of, even on your PC maybe. So yeah, please do take a look, maybe after the session or whenever you're free. Okay. So yeah, Gautam, you want to add anything more on this?
No, just one point. So yeah, this is all great, and coming from all the professors and lecturers we have, educators we have, why it matters, right? So oftentimes what happens is when people come for interviews and we ask them what project you have done, they try to explain the entire project, and then when we say, okay, which part you worked on, right? And they struggle to either understand, or they give very generic answers like, yeah, I took care of the code and I took care of the the testing and those kind of things. Instead, if they can say, hey, yeah, this is a good question, and we split this entire project into these small pieces. Database is one piece, front end is another piece. Say if you are using any like email service, there email is another service, and I took care of these one or two pieces. Okay, then that gives us the confidence, oh, these guys really designed these projects and then worked on those, and they are familiar with the terms, so we can easily connect to them. So why it matters is really that, that's the purpose behind including this topic, although this is a bit advanced one. Yeah.
Yep.
Can I move to next slide?
Yeah, sure.
Okay.
Yeah. So this is more of a pictorial representation of the same services which we talked about earlier, and just wanted to add one more thing here. So probably not relevant to the microservices part, but whenever we visit some shopping service, right, what we do, we take out our mobile device, or we log into our PC, and from their platform, from our personal computer, we type the shopping website, right? So what happens at that time behind the scenes? So this is something a lot of students or a lot of candidates who come for interviews are able to explain, but there are a lot who struggle to explain these things also, because whatever happens right from you open the Chrome or Firefox or some browser until you reach the website of your interest, right? So all the things which happens, all the computer network concepts, right? TCP/IP stack and so on. So some of the all these things are already taught in your computer science syllabus, but somehow students are not able to apply that when they actually do that thing. So if we can probably through our vivas or wherever applicable, if we can put some of these practical type of questions, it might help them to stick these concepts in their minds, so that next time when someone asks, okay, where is this session layer or wherever the TCP/IP layers, right, are used, they should be able to easily correlate and say, yeah, here it is. So yeah, that is just a side note though. And one other thing I wanted to tell, as I said, this may be a bit of a advanced topic. So how do we make students understand these better, right? And we always believe, correlating the things and checking from our environment, right? Because I mean, we believe there are patterns everywhere, right? Even from our real life, we can take examples and apply them in the computer science and see, okay, maybe, this is similar to that, right? So in that sense, so where do we see this microservice kind of architecture is, take an example of your car, or take example of your computer itself, right? So there are different components which are connected through some standard interfaces, right? In the case of car, you have your engine, you have your alternator, whatnot, tires and everything, and they're all connected through some standard interfaces like couplers or so on. And same in case of your computer also, right? All these different units, right? Memory blocks, or your processor itself is connected to the motherboard through some standard interfaces, right? PCI or there are a lot, SPI and so on. So basically we can take these examples and correlate so that students can probably understand better, okay, this is nothing rocket science, it's similar to what we see in real life also. Okay, this is how even my computer is, right? And even for the scaling, for example, we said if there is a lot of traffic in your website, right, shopping website, you need to scale up, or cloud helps us in scaling up number of servers in the backend, so that it your service is not impacted. So if you want to correlate that example with your PC, right, your memory blocks, let's say you installed some heavy software, right, which requires a lot of memory. What you do, you maybe not the case with nowadays with laptops, but in the olden days with the computers, you take out the memory chip and you replace it with a higher one, right? And essentially it is scaling, but it's just that it's all happening manually and it's not automatic, and the automatic part is provided by the cloud, right? So I always feel some of these correlations will help us understand the things better. So you can see if it makes sense to use while explaining some of these concepts, which if already are not there, will be coming soon, definitely in the academia as well. Okay.
Yeah, just want to add a couple of things there. I think, Dhananjay, we are talking a lot about shopping services and online streaming and Netflix.
Yep.
And Hotstars. So
yeah.
this doesn't mean that AWS or cloud platform in general is meant for those. It is heavily being used for AI ML. Say, for example, your students, right, or you yourself, or we do that often, right? We write programs like Python programs to do some data analytics or AI ML, right? Where do you run that code? Usually people run on laptop. Why run on laptop at all? You have free AWS account, you can get and easily run it there and demonstrate to the entire world, right? And you will get plenty of examples also there, plenty of things along the way, learn a lot. So don't want to give that impression that this is a solution for the shopping and streaming and entertainment only. It's everything that you can imagine as a computing in any way. Cloud is an answer. Okay, so just wanted to highlight that point, because we have been talking about this. We didn't realize while putting together the slides also, but just want to make sure that it will come across as a solution for those. Anything that you can imagine for the computing power, storage power, AI, ML, you name it, anything related to computing and programs, cloud is a platform. All right. Ramakrishna sir, just want to ask one question. We are about 1.5 hours. So do we want to take a break, or we have about half an hour more of things to cover and then open for questions?
So no, sir, you continue, sir.
Continue. Okay. Yeah.
Let us have break. Yes.
Okay. Yeah. Thanks. Hope we are not boring you. And more important, it's a Saturday afternoon. I know, after good lunch, what it is. But hope this is helpful.
Sir, I think the participants are also very interactive. I can see the chat box, many questions they are sharing.
Great. Yeah. Good to hear.
Boring.
Yeah. So just we'll take a few questions, because the next slide is about what are the next technologies. What patterns are used in microservices? So microservice itself is a pattern, but there are multiple sub patterns within those. For example, in this diagram that you are seeing, this is called aggregation pattern, right? So because all the other microservices are aggregated at one service. Okay. So similarly, there are API driven services, and multiple patterns are there. Not top of my head, I can't recall, but there are multiple patterns used here. Okay. And WireMock, can you give some information about WireMock tool? Just heard that term, don't know much about it and never worked on it, but it is essentially a simulation tool for the servers. So say, for example, you want to test some APIs. When we say APIs, it is HTTP or REST. I mean, HTTP probably you all understand well. So you can write just the HTTP client without actually developing the server. So this is where exactly this microservice also comes into play. Whoever is writing the client part, HTTP client part, don't need to already have the server already developed, right? Usually these two developments go in parallel in two different teams, right? And the client guy can't wait until the server is ready. By then it will be late, right? Entire project will be delayed. So instead, a lot of these mimicking or simulation tools are in the industry, and WireMock is server-side simulation. So you can simulate a server without having actual server, and you can program it very simply to return back whatever your client is expecting, just so that you can test the client part. Okay, so hope that is clear. It's essentially a simulation tool for quick, easier testing. Please share some information about Bitcoin. Sorry, not experts in that area. At least I'm not. And kind of hard to comment on that. Okay. But what we can do is, there are exploitations in the code. So this is where the cloud security comes into play. This is the real life example that happened, right? You all must have heard about term Bitcoin mining, right? So if you have a free computing power, endless free computing power, you can mine Bitcoins. Okay. But typically the cost of mining is more than what it is paying off nowadays, right? So it is not worth mining on your computer. Then what hackers are doing is getting into cloud on someone else's account. Okay. So let's say somebody's account is not well protected. They get into their account, launch the servers, mine the Bitcoins, and make money out of it. So these are hackers. Okay, so that is one area where Bitcoin mining is essentially a computing power, right? And cloud has virtually endless computing power, so you can mine Bitcoins, but the cost of mining is more than what you get out of Bitcoin. So mine on someone else's servers. Okay, so that's the thing that is hackers and bad guys are doing. Okay, how ML is used in cloud computing. Okay, so this is an interesting question and maybe a topic by itself. See, machine learning is essentially a program. You use various algorithms and various Python or Go modules and integrate into what you want to learn, how machines need to learn, and run it on a computer, right? So what cloud provides is that platform to run it. Okay, so the cloud computing is a platform to run any program, and ML happen to be one of those programs. Here is an example, right? Again, I'll give you an example of uploading an image, because uploading a pic, because all of us can correlate easily with that. So you uploaded one group picture, your class group picture. And as soon as that is uploaded, an ML algorithm can be run on the cloud as a Lambda service that I've said, without server. And that service can go get that image, run the ML algorithm to tag everybody's face, isn't it? We see that all the time, right? I mean, Google is so good at it. So Google's machine learning and face recognition and tagging algorithm is running on their cloud, GCP cloud, I'm pretty sure, to tag everybody's pictures. And does it need to do at the, like, and the peak hour? No, it can do it at the leisure, right? When nobody else is using computers, weekend holidays, nobody else is doing anything. It can go grab all those images and tag all of them. So that is machine learning running on the cloud and tagging your pictures, right? Similarly, you can run any machine learning algorithm. Okay. Hope that is clear. What are the benefits of machine learning in cloud? Yeah, just as I mentioned, see, machine learning itself is a whole different subject and field, right? And the cloud is a platform on which you can run machine learning. Okay? So machine learning needs a lot of spiky computing. So say, for example, you really want to run extremely complicated algorithm that takes only 2 hours, but needs extremely high processing power. You need, like, let's say 50 CPUs or 48 CPUs, right? In our laptop, hardly we have, like, 2 or 4 CPUs, right? Now, what do? We handicapped, I can't run it anywhere. I wrote a cool ML program, but that needs 48 CPUs to run. It's such a parallel processing, so intensive. What do? I go to cloud, hire that, take that, or rent it. Rent 48 CPU machine. You can do all of that. Maybe in different session we can show, like, it's easy. If you go to AWS web interface, you can figure out easily. So you can launch any machine of any size for any duration you want. So you can say, I want 48 CPU machine, virtual machine for next 1 hour. How much you pay? Maybe 100, 200, 300, 500 rupees at the most. You don't need to buy such a powerful computer. Now, all of a sudden, you are enabled to run your cool machine learning program on cloud. And after 1 hour, you tear down that VM, you don't pay anything more. So it is such a cost effective, and it enables the researchers also to run, any of these top machine learning. So that is, can we use cloud GPU? Exactly. So I think, Dr. Sharma, I think I have covered that. Yes, you can. Cloud GPUs are being hijacked and used also. But a lot of times what happens is the cost of those GPUs exceeds the cost of, what you get out of it, after you mine, right? After you mine, you may get 0.0001 Bitcoin, but the price you will be paying is more than that. So it is not worth it unless we hack into someone else's. Okay. So this is a common pattern, but as the Bitcoin price or any of these cryptocurrency prices increases, that equation can change. Okay. All right. Yeah. Great questions. Thanks for those. And that definitely makes the things interactive. Right.
Yep.
So moving on to the next one. So this is the next step, right? Dhananjay, yeah, back to you.
Yeah, right. So I think, any, slide or topic on microservices is incomplete without talking about Docker and Kubernetes, right? So before we get into Docker, let's understand the container first. So what is a container, right? So as you can see in that image, it's a container ship, right? Evergreen, I'm sure you must have heard earlier, which was stuck in the Suez Canal. So basically, container is nothing but something inside that you can, keep some, material, right, in the physical sense, and you can take it anywhere. And when you open it, you will still have that material, right? So in the programming side also, or in the, microservice world, a container is a similar thing. So if we take an, problem statement again, right? Usually what happens is, let's say you write a program, right? It can be a C or C++ or any, right? And it all works fine. And it works well, gives you the output when you run it on your computer, right? You might be using certain version of GCC. Now, you take the same program and take it to your friend's, laptop, or, in your lab exam maybe, and try to run there. And it doesn't work, it fails. because there may be some incompatibilities or the version might be different and so on. So, you have to debug everything and see why it is not working. Is it because of the code, or is it because of some, environment like GCC version and so on, right? So that is precisely the problem which these containers solve. So basically you build or you compile your thing in one environment, right? And you package that environment in a container, right? And that container you should be able to run or use in anywhere in the world. So that is the basic idea behind these containers. Whatever whatever runs on your computer can run anywhere else also. Okay, and it's not just that. There are few more things to it. So whatever is there in one container, right? It's all well maintained and well contained, so it shouldn't affect or interact with the other containers which are on that ship, right? So it provides that separation, or it provides that independence as well. So that is one other major principle of this use of containers. Okay, now if we take what Docker is, right? The next one is Docker, right? So it is one of the leading software framework for building and running and managing the containers. So from Linux point of view, if you have to see, it is nothing but a process. Okay, Linux process, basically a daemon. It has quite a few components like Docker D and so on. End of the day, it is a framework using which you can build these containers, right? Write your code, package that container with your code, and ship it to anywhere. And there, if they have the same Docker running, right, they should be able to run that container or run your code. So that is a basic idea behind these containers. Okay, now next one is Kubernetes, right? That is again one other buzzword we keep hearing and using. So what is Kubernetes then? So we see a lot of containers, right, on that ship. Now, which one we can group together, which one we have to keep where, what all these containers are doing, are they healthy or not? So we need a way to, check, monitor, and orchestrate all these containers, right? So Kubernetes is a technology which provides this. Now, I haven't written many text on this because there is a link, right? Medium link, which you can refer, and there are some references on how do we learn Kubernetes and what are its components and so on. Because it's a topic by itself. It won't even be we can't even cover in 1 or 2 sessions, right? And it's heavily used also, so will be very helpful if for you to go through that link, the medium.com link, and get some details on that. And by the way, one other thing, we keep posting these links, right? Medium.com, it can be, or can be Gartner, and there are some other blogs like Light Reading and so on. These are the things even we keep on reading every other day to get to know what is happening in the industry, where are we heading, and what changes are happening, and what are the buzzy things. So if we can put these in the academia itself, right? As in, you can also go through this, and you can suggest your students also to subscribe or go through these blogs, so that they also get an idea of how the world is changing with respect to technology, and they can decide on their career paths and interests and so on. So yeah, that's why I haven't put more on Kubernetes, but yeah, feel free to go through the link to learn more. Okay.
I just want to add one point there. Kubernetes, by the way, is developed by Google, and it open sourced everything. And they did an excellent job in understanding the IT problems and the overall software deployment problems, and really address that. So if any of your students or yourself is interested, that's a great topic. Okay. All right. So there are a couple of questions just want to take before one. How ML is used in cloud computing? I think that was answered. So basically, cloud is the platform. Cloud computing is a platform where any program can be run, and ML happened to be one of the programs that is compute intensive, and so that's why it is one of good applications to run on computing without each one of us having big computers. Okay? How are Kubernetes and Docker related? I think that question is in a way answered, but maybe can reiterate. So Kubernetes is essentially a Docker management engine, if you will, right? So imagine this way, right? As Dhananjay mentioned, just on this ship, there are so many containers, just physically, forget about all the technology, right? And who decides which of these container goes which part of the ship? Okay, so let's say you compartmentalize, all the perishables goes in one place, non-perishables goes in one place, and the livestock goes in some other place, right? So that's a common theme in shipping, right? And now who decides? Somebody need to be there to decide, hey, this guy is non-perishable, so let's put it in the somewhere in the side of the container ship. Okay, and these are all livestock, so these need to move up front, and somebody need to monitor that continuously. Right? So who decides all of that? So somebody in the clerical office will be doing that, and somebody in the management office will be doing that in a physical world, right? Kubernetes is exactly that. It is a container management engine, in a simple words. In more fancy words, it's a container orchestration engine. Okay, but essentially it is managing the containers. Okay. Hope that is clear. Dhananjay, anything more, or can I move on? Next slide.
Yeah, I think we can move.
Yeah. Okay. Yeah. Dhananjay, you talk about, so we are getting into the non-technical kind of part, and kind of will be wrapping up in 2-3 slides.
Yep.
Yeah.
Yeah. So certifications, right? So some of these, what we see, when we get to interview some of the fresher graduates, is some of them already went through some of these certifications. So basically, this gives the students good idea on how the platforms work, right? Because yeah, sessions is one good way of learning what AWS is, for example, or what GCP is, and so on. But when you put them on a certification course, right, which will be spanned anywhere from 2 to 3 weeks up to months, right? So they will be doing a lot of groundwork, as in lot of covering a lot of theory parts, then doing a lot of demos, hands-on work, and at the end they will be spending time learning things because they have to give an exam, right? And after that, once they are certified, that will be good on their resume as well. But the main intent here to put this is this is one way of disciplining ourselves to go hands-on with some of these technologies, because these sessions will help definitely, but we might attend the session and say, yeah, it was good, done. But once we enroll into some of these certification things, then there will be that target of, okay, I need to get this certificate. So yeah, whatever I have to do, I'll do, that kind of mindset will be there, right? So that's why probably would suggest, if it is feasible, probably through your colleges, for the students, you can always suggest, and making it mandatory or optional is up to us. But what we see is in some of the autonomous colleges, they make it probably kind of mandatory for students to complete one of these certifications in probably in their 4th year. So in a way that is good, because as I said, they will be going through all that exercise of learning hands-on and so on before they get the certificate, right? And as the industry people, we will also know whether a certificate was simply they completed it from some dumps, or they really put their hard work efforts and then only they complete it. So in a way, it is a good exercise, and probably you can check with your college and management if you can suggest or make it kind of mandatory for students to have one of these covered. Okay.
Yeah. Absolutely. And not only for the students, I mean, a lot of our colleagues goes through this, and we are also going through some of these exercises and getting the certifications, because that is one good way to prove to the industry and whoever, wherever we are achieving, right? Like apart from learning, wherever we are aiming to get to, it's a good way to prove the credibility, like, what you know already without actually even looking at, without actually talking to you yet. Right. So this is a great step to kind of like, enable yourselves or the students. Okay. All right. Yeah. So now getting to the key takeaways. So let me just quickly check any questions. No. Okay. So yes, we have covered a lot of ground, right? Started off with why we are doing it, and cloud computing, spent quite a bit of time there. Although we didn't give any hands-on, but like, we'll be happy to provide those leads. It's quite easy, believe me. Okay. So the key takeaways out of all of this, just summarize those in a couple of slides. Cloud computing is a platform. It is not a solution. Sure, if you think platform is a solution, yes, it is a solution, but it is a platform to run your code. If you wrote even a simple Python hello world program, you can run it on cloud. Nobody is stopping us, right? And what we recommend, as like, being in the industry for long, all the students should be aware of cloud computing, and all of them should get their free accounts in the first year itself. Okay, the question is why not, right? Because free tiers are available from all the major cloud providers, especially for students and faculty. Anybody can get 1 year, but need to give the credit card. But student and faculty don't even need to give the credit card. So what I didn't check is, because I'm not from academia, couldn't check whether, like, each college need to register with them or something. But I'm pretty sure they will be very interested to give these free tier accounts to everybody. So we don't see any reason why every computer science or engineering student can get a free account in their first year itself and start experimenting. It is not part of curriculum, understood, but this is what the industry is using, as we have seen in past, like, hour and a half, right? And other thing is, once they have that, all the projects, minor, major, if it has code, it has to be on the cloud first strategy. For the organizations, as we have seen, like, it's already there. And for the academia also, cloud first strategy. Sure, if somebody has IoT devices, sensors, and Arduinos and Raspberry Pis, sure, that is not cloud. But what the data that they generate can get to the cloud, because just like how we have seen, like, about 10 services, IoT is also a service. It can draw nice graphs for you so that you can focus on your core IoT things, right? So even including IoT, everything can be on all the projects. There is no reason why we can't, right? That is because the core of the cloud platform is, you bring in the idea and you do proof of concept in the matter of hours and days. All the ancillary things around it, like, be it drawing graphs to data analytics to, like, providing database, it's all taken care as part of the cloud platform. Right? So you write that core program and run it and integrate with different other services from the cloud. So this is a little bit advanced, but once people get hands-on, it will become easier. Okay. And this really opens up opportunities for everyone to explore more technologies. Okay. And it is community driven. This is where is the opportunity to get into open source world as well, because you can easily get all the things from open source and run it on the cloud. Okay. In the VMs, virtual machines to start with, and containers as a next step. Once you get to the platform and the VMs, containers is just the natural next step. Okay, and it is easier to when students and faculty talks this language, right? It's so easy to connect to industry experts. We'll be talking the same language at that point. Okay? And it is easier to communicate, easier to incubate the ideas and build on top of. So this is another thing, like, I don't know how feasible it will be given the restrictions and guidelines. Typically in the industry, what we do is we develop some programs and, like, solutions. And for years after that, we keep enhancing that. We keep making it better. We keep building new service on the top. Okay. So that is the key pattern. But in the academia, what we see is, every project, every year is different. We don't build on top of the projects that were built in the previous years. Then we may have to question why not. So last year, guys build this project, these students build this project. Can we enhance it? Can we make better out of it, or can we build new, usage of that? Right. So that is another thing. Maybe feasible, maybe not. Okay. So obviously, this boosts the resumes. Okay, and makes the students industry ready, and then we'll get to the microservices pattern in the projects. Okay. So it is all feasible. If you have to take one key point away, why not have even our first year students have their cloud account right from day one? Okay. And here is the second takeaway, right? I drew these two golden triangles I call. Pretty much on the PC you develop, on the left side is your PC or laptop, you develop the things, the programs, you write the programs, you use the GitHub to store your code, you use cloud computing to run it. So in a way, you will never run that your program. Sure, you will test it on PC, maybe, but you can test it on cloud computer or cloud also. You don't need to test even on your PC. You can develop, push, and then run it on the cloud. Okay. So what this enables is you can demonstrate this to anybody in the world. You can't, a student don't need to take their PC and show this is running and showing this. Why not on the cloud, so that anybody can access it from anywhere in the world, right? So that's the great advantage. And all of this is, of course, enabled by internet. Okay. And second one is, learn. This is what I think, including ourselves in the industry and more so in the academics. Learn, baby step. That's the first step. Experiment, nothing to lose. Back then, when I was from EC background, burned so many capacitors and resistors and inductors, whatnot, right? So many boards. In the computer world, you can't damage it. Experiment and fail. That's okay. If it succeeds, great. Nothing like it. That gives energy for the next one. But if it fails, that's okay. Go back, learn again, learn from the mistakes, and encouraging that failure is also important. Like if it doesn't work, that's okay. Like you just repeat it. Okay. So that experimentation. I mean, this learning is the first baby step, and then get to the experimentation. Whether it is success or failure, keep repeating. Okay. So these are the couple of key things that I would like all of us to kind of take away. Okay. And then have this one slide. Okay. So I talked about a lot about cloud, you can get the accounts and all that. Okay. And here is a thing that came to mind, when I was thinking about academics or academia, including students, how they can use the cloud computing. Then just Googled and came across these, and something came to my mind. In quite a few countries, including US, McDonald's usually have these playgrounds. Okay, kids playgrounds. Read a research paper about it. Okay, why? It is not just to attract the families with the kids, but they are building their future customers. Once the kid starts playing here, that sticks to their mind, and they keep going back to there. That is what the research paper explained it very nicely. Okay, so it is not only they have the current customers as families, but they are building their future customers. So that's exactly why all these cloud providers, all the big cloud providers like Amazon, Microsoft, Google, they are all giving free accounts and focusing on educators, because once you get hooked to that cloud, there's no going back, because that's the power of it. Right? So as you can see, AWS Educate, free students, that is from Microsoft, and completely free. Google offers up to $300 worth of computing power and storage power and all that for free for every student. And I'm pretty sure if any of the organizations and maybe this entire AICTE is interested, they should be able to negotiate even more with these guys. I'm pretty sure these guys will be interested in giving it, because they are preparing the future customers for their products. Why not? Why won't they? Okay. So hope that makes sense and sticks. All right. That's pretty much what we have to present. Suggest students to go. Yeah, just looking at the question. Sir, can we suggest students to go about cloud computing business? Sorry, could you please elaborate, Rohan sir, about go about cloud computing business? Feel free to unmute yourself and ask or post. Can you suggest students to go about cloud computing business? Buying and selling this as a service. It's possible, definitely. Not an expert in that area, but okay. So there are two ways, right? One is buying and selling the products. Yes, that is totally possible. Okay. So recently I heard a podcast and also read about it somewhere. The niche products, right? So it is no longer going to be like, may not be Amazon driving the entire thing. It is cutting the middleman yet again, and connecting the producers directly with the consumers. Some people are coming up with those kind of platforms. So that is essentially like, buying and selling platforms. So yes, it is completely possible to build those kind of platforms to buy and sell the things using cloud. Yes. If they're trying to experiment, that is a place to go, definitely. Okay. All right. Yeah. And here is our LinkedIn profiles or LinkedIn places. Feel free to connect with us and ask questions. We'll be happy to answer there. Okay.
Yep. There was one question, right, Gautam, earlier.
Yes.
So what are the obstacles in the integration of technology in education? Yep.
Okay. Yeah, that's, let me go back. Benefits to the information. Okay. Okay. Oh yeah. Vignesh asked, what are the obstacles in the integration of technology in education? I think, pretty loaded question and have to think really. The obstacles is, I see it as a mostly first step, okay, and giving that lead to the students, okay, and the industry connection. What can enable it is industry connection. Okay? So let's say if we enable some of the students, not all the students may be interested. I mean, we were there some few years back, right? Like as students, not everybody may be interested, but 20%, 30%, 40% of students may be interested, and give them enough leads. Okay, give them the paths, just the links to explore, and maybe some webinars, probably, right? To cloud computing for computer science students. Okay, for example, they just attend and see, and that will be more of a hands-on session, not the theory session, right? So this is how easy to open your own account, and this is how easy to set up something, and this is how you launch an instance, and then you write your programs there, whatever you want to do, right? So that is the next level. So the main obstacles, I think, is the first step, and the industry and academia connection is what I feel. Dhananjay, you want to add anything more to that?
Yeah, just one thing though. The main obstacle, as in, even in academia, we can't just go and teach whatever we want to, right? We have to be within the rules, and there are a lot of things put in place by the universities and the government agencies, right? So, but probably what we can do is, even outside of the syllabus or outside of the curriculum, right? We can give these pointers. I mean, we need not like teach everything, right? We need not do the hand holding, but at that level, once the students are in college, what we expect generally is you give them the pointers, and then they should be, those who are interested should be able to pick up and learn it or try it by themselves, right? So probably that is something we can do as a in addition to whatever we have in the curriculum. I'm not saying whatever we have or the rules and all that is bad. It's definitely good, because it's those are put in place keeping the diverse people and all that in mind, right? India, or even within a university, it is not just one or two colleges. They have to keep in mind all the students and all areas and so on. So probably we can add these things also along with the existing curriculum, so that people will be tech savvy, right? The students will be tech savvy, and they can learn the things. Those who are interested, even if 10% of the students out of all take up some of these, right? So that will definitely, help not only them, it will help the industry also, right?
Yep. Agree. Okay. Yeah. Yeah. Open for any other questions, comments, anything that you want to share.
Participants, any questions? Any more questions? Sir, I think most of you have shared their questions in the chat box.
Mhm. Feel free to repost if we fail to answer anything. That will be fine as well.
Yes, sir. I think both of you taken the revenge very well, sir. If I see many other interactive sessions are done, they shared with the questions. Yeah. So yeah, if you have many doubts or any, want to exchange any information, please. Both have them shared their LinkedIn thing, so you can interact with them. I'll hand it to Ms. Kirtan. Over to you, ma'am.
I thank both the resource persons for having a highly informative, interactive session. The information shared by you has helped all of us a lot. We look forward to have more sessions from both of you, sir.
Sure.
Thank you so much.
Yeah, thank you. We'll be glad to help in any way we can, and feel free to connect with us. And any way we can, educate and also empower the students, we'll be happy to. Thank you.
Thank you.
Thanks.
Thank you, sir. Participants will have the next session on Monday, that is 20th. The first session will be Dr. K. Raghuveer, sir, on the topic concepts and recent advances in recommender system. The timings, the session will start from 9:45. And about the contents and the recorded sessions, it will be shared at the end of the 6th day. I request all of you to fill the feedback form. The link has been sent in the group. Kindly give your valuable feedback. It is mandatory for the certification. Thank you, one and all.